Very pleasant morning. It gives me an immense pleasure to extend a very warm welcome to you all. On behalf of Internal Quality Assurance Cell, Department of Computer Science, Computer Applications, and Mathematics of Krishnaswamy College for Women and MIT Square London, organizing a 2 days international conferences on advances in applied sciences, technologies, and mathematics 2025 in collaboration with ICT Academy. The aim of the conference, by providing a new forum for exchange of knowledge and experience in the field of applied sciences, technology, and mathematics, to explore new development and expand their professional networks. The attendees can engage in discussions, new collaborations, and exchange insights on both cutting edges, research, and practical applications in the field of applied sciences, technology, and mathematics. Now, it is a great pleasure to introduce our session chairs. First, Dr. T. Johnson, Professor and Head, Department of Mathematics, Dr. MGR Educational and Research Institute, Chennai. Dr. Johnson is a renowned expert in fuzzy set theory with an impressive research portfolio comprising 30 journal publications and 5 international and national conferences presentations. He has successfully guided 4 PhD scholars and is currently guiding 2 more. A dedicated academic, Dr. Johnson has served as a project associate at IIT Madras and is a doctoral committee member for several research scholars. Dr. Johnson's commitment to teaching excellence has earned himself several certifications and received a prestigious Bharat Jyoti Award. Next, we have Dr. A. Tamilselvi, Assistant Professor, Ramanujan Institute for Advanced Study in Mathematics, University of Madras. With an academic career spanning over 22 years, Dr. Tamilselvi has established herself as a leading expert in combinatorial representation theory, diagram algebras, and algebraic graph theory. Her research contributions have significantly advanced our understanding of these fields. Dr. Tamilselvi's impressive academic qualifications include a PhD in mathematics from the University of Madras, as well as the postdoctoral research experience at the Institute of Mathematical Sciences. Throughout her career, Dr. Tamilselvi has demonstrated a commitment to excellence in teaching and research. We are honored to have the session chairs with us today. Welcoming, sir, and welcome you, ma'am.
Thank you, madam. Thank you.
Participants, are you ready?
Yes, ma'am.
Okay. Sir, shall we start the session, sir? Ma'am?
Okay, madam.
Tamil ma'am, shall we start the session, ma'am?
Yes, ma'am.
Okay. The first participant, now I call upon the first participant, Ms. S. Rajalakshmi. Paper ID is ICAASTM 2001.
Yes, ma'am.
Rajalakshmi, can you share your screen, ma'am?
Yes, ma'am.
Okay.
Ma'am, I can't share my presentation, ma'am.
Okay, ma'am, no worries. We will share it, ma'am.
Yes, ma'am. Screen is visible, sir. Rajalakshmi, screen is visible. Ma'am, yeah, okay, ma'am.
Okay, ma'am, you can start.
Yes, ma'am.
Madam, can you make it as a full screen? Because now it's only half of the screen.
Now it is visible, sir.
It's visible, but it is only in the part of the screen. Can you make it as a full screen? Because you can open the PDF and then can make it a full
Okay,
screen.
sir.
Now it is okay, sir?
Only it is like that only.
Now it is okay, sir.
Still, it shows only half of the screen, but only a part of the screen.
Half of the screen.
You can open that PDF. That is a PPT.
Yes, sir. Yes.
You can open the PPT and make it as slideshow manner so that it can be full screen.
Sir, now it is visible, sir.
Can you open the file, madam? Because still the file is not open. It's only a blank screen is there.
Slide is not open.
That is fine. You just open the file.
Yes, now it's okay, ma'am.
Yeah, okay, ma'am.
Rajalakshmi, go ahead.
Yes, ma'am. Good afternoon to all. I am Rajalakshmi. Today I am going to present about applications of probability. First,
Oh,
we see introduction. Ma'am, next slide. Yeah. In everyday life, we face earthquakes, cyclones, tsunami, lightning, and epidemics, etc., are unpredictable. These types of events are occur unexpectedly, and the result is heavy loss to humanity. If we predict the occurrences of such events well in advance based on their past occurrences with a good amount of accuracy. Such predictions well in advance of their actual happenings requires the study of probability theory. In our real life, we can see several situations and we predict the outcomes of events. It may be specific or uncertain to occur, and it deals with the occurrence of a random event and it can use to predict how likely events are to happen. The meaning of probability is basically the extent to which something is likely to happen. If we predict in general, many events of the experiments cannot be predicted with absolute certainty. For those cases, it helps predict an event's likelihood. And probability is widely used in all sectors in daily life, like sports, weather reports, blood samples, predicting the sex of the baby in the womb, and congenital disabilities, and etc. Ma'am, next slide. And basic definitions of probability. Random experiment. A random experiment is an experiment where the outcome cannot be predicted. For example, tossing a coin, rolling a dice, picking a card from a deck. In random experiment, the outcomes is unpredictable. The experiment can be repeated under the same condition, which is known as a random experiment. And sample space. The set of all possible outcome of a random experiment is called its sample space. and it is denoted by S. For example, when rolling a single six-sided die, the sample space is 1, 2, 3, 4, 5, 6. Flipping two coins, the sample space is head tail, and tail head and tail tail. Next trial. Each repetition of the experiment is called a trial, and the result of a trial are called outcomes. Example, tossing a coin, rolling a die, and germinating a seed is also a trial. Okay, germinating a seed is it with two possible outcomes: germinates or does not germinate. Um, Next, classical definitions of probability. If a sample space contains n outcomes and if m of them are favorable to an event A, then we write n of s equal to n and n of a equal to m. The probability of the event denoted by P of A is defined as the ratio of m to n. P of A equal to number of outcomes favorable to A divided by total number of outcomes. And that is P of A equal to m by n. We note that the probability of an event A lies between 0 and 1, both inclusive, that is 0 less than or equal to P of A less than or equal to 1, and the probability that the event A will not occur is given by P of A dash equal to 1 minus P of A. The probability of sure event is the probability of sure event is 1, that is P of S equal to 1, and the probability of an impossible event is 0, that is P of pi equal to 0. Next, ma'am. Example, tossing a coin and getting up head or tail is an outcome, and throwing a dice and getting a number between 1 to 6 is also an outcome. Next, ma'am. Sample space for a pair of dice. This is a dice figure. Next, ma'am. Ma'am, next slide. Applications of probability. Weather forecast. We always check the weather forecast before we plan a big outing. We might decide to delay our outing because we trust this forecast. Meteorologists use expensive equipment to understand likelihood of weather happenings. They look at the historical data combined with current trends. Meteorologists around the world use different instruments and tools to predict weather changes. They collect the weather forecast database from around the world to estimate the temperature change and the probable weather conditions for a particular hour, day, week, and month also. Next, ma'am. Next, sports strategies. To identify the strengths and the weakness of a specific team or person, assessments are undertaken in sports with the use of probability. To predict a result about the team's performance and the individual players in the sport, analysts employ probability and odds. Coaches use probability as a tool to assess where their team is strong and where more work needs to be done in order to win. Match analysis. To predict the probability of a team winning a game based on factors like team strengths, recent performance, and injuries. For example, before putting a player in the lineup, a cricket coach assesses his batting and bowling skills using his average results from prior games. Next, ma'am. In sports, probability is used to develop strategies by analyzing past performance data to predict the likelihood of specific outcomes. Mm, Specific outcomes, allowing coaches and players to make informed decisions based on the most probable scenarios. Next, ma'am. Next, lottery games. The rule of The rules of probability dictate that the only way to win the lottery is to be part of it. Then you can further increase your odds by playing frequently. Each time you play the lottery, there is an independent probability frequency, like with the coin flip where you can win or lose. While buying more than one ticket can indeed increase your chances of winning, this does not give you a significant advantage in beating the odds at all, at least not in any amount that justifies the additional cost of tickets. Next, ma'am. And the games, for example, blackjack, poker, gambling, all sports, board games, video games use probability to know how likely a team or person has chances to win. And staffing in grocery stores, when deciding how many employees to plan to work on a given day, grocery retailers frequently consider probability. For example, a grocery store, for instance, might utilize a model that predicts that there is a 75% probability they will see more than 800 people on any given day. Next, ma'am. And shopping recommendations. When it comes to shopping, probability is used in various ways, including predicting customer behavior, personalizing product recommendations, optimizing inventory management by past data to understand the chances of customers purchasing specific items or engaging with the marketing campaigns based on the demographics and buying patterns. Next, ma'am. Determination of find gender in the womb. When determining gender in the womb using probability, the chance of having a boy or a girl is considered to be roughly 50 by 50 because the sex of the baby is determined by the sperm. Either an X chromosome or a Y chromosome with each possibility having an equal likelihood. Next one. Here is the figure. Father has a XY chromosome, mother has a XX chromosome. Then the possibilities of uh, daughter, son, that means XX chromosome and XY chromosomes to predict the sex of the baby in the womb using ultrasound scans or some ancient methods. Next month. Mm. Determination of the blood type. Determine a person's blood type using probability. You can analyze the known types of their parents by creating a Punnett square, which allows you to calculate the likelihood of inheriting a specific blood type based on the possible gene combinations from each parent. Considering that blood type inheritance follows Mendelian genetics with A and B and zero alleles. Next one. Ma'am, next slide. Mm. Here is the Punnett square to determine the blood type. Yeah. Next slide, ma'am. Ma'am, next slide. Yeah, thanking you. Um, if you have any doubts or questions, please ask to me.
So, right, Rajesh madam. So, you have a good presentation, right? So, am I audible to you?
Yeah, okay, sir. Yes,
Okay,
sir.
just tell me because you have shown so many applications of probability, but you should tell clearly where we can apply probability because there are some different methodologies are there. We can apply numerical methodologies. Do you know? There are some numerical methods are there to find the optimization, right? And there are some fuzzy tools are there to solve certain types of problems. So can you tell me in which type of problem we can apply probability? Because we have numerical analysis for certain problems, we can apply fuzzy set theory to certain type of problems. In the same way, we can apply a probability only to certain type of problems. Can you tell me where we can apply probability?
Sir, actually, fuzzy set and numerical methods also, this is my new subject, sir.
No, no, news.
I,
I'm not asking where because if you give a problem, okay, how can you understand this can be solved by probability? Because that's some problem. If you give a set of equations, right, that cannot be solved by probability. That can be solved by some numerical methods, right? So in the same way, if your problem is given, how can you understand that can be solved by the idea of probability theory, where we can apply probability? Because you have done so many things, tossing a coin, starting from tossing a coin, and then you can tell, then medical also you tell, right? But you simply tell a simple thing, in which type of problems we can apply probability, because you have told that thing in the very first slide itself. Can you move on to your very first slide?
yes, sir.
Here you tell one simple thing where we can apply probability.
In any other field, sir?
Not really. If you give up a problem is given, right?
Yes, yes,
Right?
sir.
Then you should know we can apply probability on this particular problem. Suppose if you're tossing a coin, it's a problem, right? We want to
Yes.
toss a coin, right? 10 times. I want to know how many times I will get hit, right? So for this particular type of experiment, I can apply probability. Why I apply probability for this particular experiment? Not any numerical
Sir,
methods, not any facilities.
because of likelihood, if, to calculate the possibilities to get a even.
No, it's there. The answer is there in your screen, sir.
Mm. Mhm. Sir, in distribution methods.
No, no, because whenever the outcome, right, is unpredictable, right? It's a trial and error process, right? So whenever we conduct an experiment, the outcome of an experiment, you just tell there you can face unpredictable. So which are the things are unpredictable? It can be done only through trial and error process, right? So that is the basic idea, right? We can do the random experiment and then we can get the trials. Okay, you've shown the so many definition number in second slide and third slide. Okay, so whenever you can experiment and you can make a trial and we have a sample space. Okay, for that type of problems only you can apply basically probability theory, and basically the rough definition of probability theory is number of favorable outcomes divided by total number of outcomes, right? There the
Yes,
outcome
sir.
is unpredictable. Very simple thing. There the outcome is unpredictable. Whenever the
Unpredictable.
outcome of thing is unpredictable, so it requires a trial and error process. Particularly, suppose whenever we conduct a sample survey, right? So sample survey for because there are hundred thousands of people are there, right, in a city, but we can't go and ask each and every one which type of soap you are using, all these things. So we take a sample thing. Using the sample, we can predict, right, or forecast the bigger thing. So whenever, so for this type of problems, okay, we can apply probability and basic statistical methods. Right. So that I'm asking a simple thing where we can apply probability.
Yes, sir.
Huh? So that right. So
Okay,
because whatever I'm explaining is only a layman perspective, right? So what, but original probability is very high manner, right? But I'm telling in a very simple manner. Whenever the outcome of an experiment is random, right? Then we have to use probability on that thing, right?
yes, sir.
Okay.
Congratulations, Maladi Lakshmi. As a MSc student, you have done something good, but you have to go through whatever you have done is studied in your MSc only, I think so. You
Yeah,
have to
okay.
give some more concepts which is new to the thing, right?
Yes, ma'am.
New concepts only you have to bring it here. Whatever the results you are showing, whatever you are showing here is just a concepts of MSc level, right? You have to show what is new, what we can do. That's what sir explaining, where we have to apply, where numerical methods, fuzzy and all those things. Maybe you may not know all those subjects, but at least whatever you know, you can apply. Even in algebra or whatever the thing is, analysis, wherever you can apply this probability and you have to show those things. Okay, ma,
Yes, ma'am.
congratulations. You can.
Yes, ma'am. Thank you, ma'am.
Yeah. Yeah. Ma'am, you can call the next person.
Okay. The next person is Dr. Sadashiv. Sir, are you ready?
Yes, I am ready, ma'am.
Kindly share your screen, sir.
Okay, I am sharing my screen.
Okay.
Is it visible, my screen?
Okay, sir, you can go on.
Yes,
Go on.
sir.
Yes.
Okay, I will start my presentation.
Yes, sir.
Myself, Mr. Sadashiv Ji Dapke. My topic of presentation is on rectangular S matrix spaces. Table of content. Contract introductions and preliminaries, examples of S matrix spaces, our main results and references. Abstract. The purpose of this paper is to study rectangular S matrix spaces. We established common fixed point theorems in rectangular S matrix spaces. We provided some example to support our result. We first of all discuss some preliminaries and basic concepts.
Sir, your voice
Sir,
is
you are
not.
Sadashiv, sir.
Sadashiv, sir.
Sir, your voice is not audible, sir.
Some researchers, Dage, Galar, they introduced
Sir, Sadashiv, sir. Your voice is not audible.
Sadashiv, sir.
Sharing.
Is my
Sadasiv sir,
is my screen
sir, your
visible?
voice is not.
Okay,
No,
okay.
sir.
Okay, there is some problem. Is it visible now? Okay, sorry for there are distant
So your screen is visible, but your audio is not.
We discussed some basic preliminary definitions. The Bransarelli defined rectangular metric space. He defined take a non-empty set X and function D from properties where mostly property third and which property is likely similar to triangle inequality, and if they satisfy these three properties, then Bransarelli named as rectangular metric space. After that, Sedgwick defined S metric space. He modified the last properties of Bransarelli and it is given as rectangle inequality, and here he takes A x y z belongs to for all x and he named as this metric space as S metric space. And after that, this metric space is modified by Adewale and he renewed and coined the new metric space, and modified metric space is named as rectangular S metric space. Now actually our work is taken in this rectangular S metric space. Here Abbas gives coincidence point definition which are useful for our results. Here Sedgwick defined the convergence, Cauchy sequence and completeness in this S matrix and rectangular S matrix space. These definitions are coinciding with the definitions in the matrix spaces for the convergence, Cauchy sequence and completeness. And this one example, which is for rectangular S matrix space. This one is the second one example, which is provided for rectangular S matrix space. Now, actually, we are focusing our main results. We proved these results for fixed point theorem. We take S matrix space and take two functions f and g be a self-mapping f of x, fy, fz is less than or equal to k, yes, gx, gy, gz for all x, y, z belongs to x, where k belongs to 0 to 1, and it satisfies two property, f of x is subset of g of x, and second one is if g of x is complete, then we proved that f and g has unique fixed point theorem. To prove this theorem, we have taken x0 for arbitrary point of x and we are getting that f of xn is equal to g of xn plus 1 is equal to y of n plus 1. And one that less than or equal to k square s g of xn minus 1 and respectively. Continuing this process, we getting s of g of xn plus 1, g of xn plus 1, g of xn is less than or equal to k raised to n, s g of x1 and respective terms. And after that, we proved this result for yes, ym, and after taking some terms, calculating and mechanically, we proved that this term is less than or equal to 2 raised to k n minus 1 z plus k raised to n minus 2 z 1 minus 2 by k raised to minus 1. After that, we are applying the limit as n tends to infinity. We get that s goes to 0 for yn and ym and limit n tends to 0 of s for g of xn, g of xm. And by applying Cauchy sequence and completeness property, we get that g of xn goes to p as n tends to infinity. That means we claim that gp equal to p. For this purpose, we are taken s of g of xn, g of p, and we find that this term is less than or equal to k of s, g of p, g of xn, g of xn. After taking the limit as n tends to infinity, we get f of p equal to p. And lastly, we proved that f of w equal to g of w equal to w. F and G have common fixed point theorem, and this one for uniqueness. And by using these results, we are taken some particular results. One particular results. Here we take k in between 0 and 0.2. If here f and g satisfy these properties, then we prove that f and g have unique fixed point theorem. For this proof, we goes on the similar line of the proof of the previous theorem, and we get lastly the proof of this theorem. In this way, in this presentation, we are proved two theorem of common fixed point theorem in S metric spaces and rectangular S metric spaces. For this purpose, we have used there is the references OK Adewale, Bransariri, BC Dage, Galhe, Sedgi, Jhar Mustafa. Thank you.
And Dr. Sadasiv, can you able to hear me?
Yes.
Okay, so how the rectangular S metric space is different from the regular metric space? Can you tell me a basic applications of basic application of S metric space?
Actually, in regular metric space, we have taken 3 points as like a track. Their options, like we are taken first 2 points are similar and third points are dissimilar, and we are getting there are various ways. And also we take 1 point from other side of the domain, and then we get the rectangular metric space. Actually,
I want to ask simple thing. How a rectangle, whether it's a rectangular metric space is a subspace of your general metric space, or how it is differ? And tell me where
metric space is a actually rectangular metric space is a particular case of metric space.
So that I'm asking. Okay, so you are taking from a general case, you are taking a particular case, that is a rectangular S metric space, right?
Yes,
so tell me where it can be applied. Or
actually, we are not studying their applications. We are just studying the fixed points theorem. What happens in rectangular S metric spaces if we apply here, which conditions we must impose to them.
So can you tell me what is a fixed point on a metric space?
Actually, there are several fixed points theorems studied by Banach and this in the metrics.
I want what is the definition of a fixed point?
Fixed point. If we
point.
are like just a constant function, if we are getting the constant function that we are getting after some iterating terms, we are getting a fixed point, and that is the point. If we take a map of India and actual India,
if you take a point from X, suppose you take a triplet from X, and if we transform
Yes.
from f of X, that X to X, right? Then we call a particular point as a fixed point from the metric space, yes. So what is the definition of a fixed point?
6 point.
A fixed point, because you are most of the results based on the fixed point, right? You are telling whether if it is complete, if it is then it has a unique fixed point. So what is the meaning of a fixed point, or what is the meaning of a unique fixed point?
That means, first of all, I will say unique fixed point. That means there is only one a single point which is fixed point. And for the fixed point, we are taken the images of our original points. We are getting only one point. If that image is contracted or that image is largest, we are getting only one point. That point is a fixed point for that point.
Oh, no, because I'm asking because you are putting unique fixed point. Unique fixed point means, can you tell me whether a metric space has only one fixed point or many fixed points?
Yes, sir. Yes.
Only one.
Okay. Unique means that is only one single point.
Okay, that you are proving. But in general, we have only one fixed point, unique fixed point for a metric space.
Yes, sir. We are getting unique fixed point theorem in metric space.
No. In general, I'm asking whether for any metric space, can you get only one element, a unique fixed point or not? Because in general, I'm asking whether a fixed point is always a unique or not.
Yes, sir. Unique. We are getting unique fixed point.
No, we are getting unique fixed point, right? But I'm asking in general, in a metric space, we are always getting only one fixed point for a particular space, or we have a number of fixed points on a particular metric space.
Sir, some condition we may get more than two fixed points.
So that I'm asking whether you are putting some conditions and then you are getting some very fixed points, or in a fixed point itself, definitions of tell a metric space must have only one unique fixed point. I'm asking a simple question.
Yes, sir. Sir, we are getting a unique fixed point theorem. Unique fixed point.
Right. That see, we are getting a unique fixed point on some conditions. But I'm asking by basic definition of fixed point, how you define a fixed point? We are getting a unique fixed point. Okay, right. I'm asking what is the definition of a fixed point?
Sir,
suppose if you want to find, suppose if you tell some XYZ, right? Because you are always taking a triplet, right? If you map the triplet, right, to the so what is the meaning of the definition of fixed point? Fixed point definition, because you are moving from X to X. You are moving from F and G, moving from X to X, right? And you can take a element from the domain and then you can map it into the codomain, right? So what is the definition of a fixed point when you take a point from your domain X?
Sir, we are getting, if there is a self map and we are getting
you are taking self map, right? So what are the elements having a self map, right? If x1 goes to x1 and some x2 goes to x2, f of x1 has x1 and f of x2 has to s2.
That is the
right?
Sir, we are getting.
Suppose if you take a function f of x equals to x square, right? Then f of 0 is always 0, f of 1 is always 1. Okay, then we can so that makes moves from 1 to 1, right? So that I'm asking. So whether it's fixed point is a unique, or we have a number of fixed points in a metric space.
No, sir. In that case, there is no unique fixed point. There are many.
Right. So that only I'm asking, right? So then you are imposing some conditions, and you are making and you are telling that the both having a unique fixed point. So, okay. Madam, madam, if you want to ask, you can ask.
Okay. So, Sadasi sir, it's better if you show that exactly what is the fixed point theorem you are using. There are so many fixed point theorems. You said yes. There are so many theorems. If you shown, then there is no question to ask which conditions we are using, which results you are using, and all those things. You have to show. And then the next thing, how the rectangular and then S metric spaces are related. As rectangular with any general metric, how the difference between rectangular and the S metric? Is there any relation? You said it is a subset of the metric with the rectangular. How it will be for the rectangular with S metric? Are you audible, sir? Sadasiv, sir?
Madam, no problem. We can move on. We can move on. Because
Yes,
we have
ma'am.
time.
You can move on, ma'am. Okay, sir.
If there is a
Next
property
candidate.
which will give the difference between rectangle and
Dr. Sir, it's no problem. It's okay to you. Okay, we move on to the next part.
Dr. R. Sita Lakshmi, ready, ma'am? Dr. R. Sita Lakshmi?
Yes, ma'am.
Okay, ma'am. You can start, ma'am.
Yes, ma'am. Good afternoon to all.
Good afternoon, madam.
I'm Sita Lakshmi from Rajashmi Institute of Technology, Chennai.
Okay, madam. First, you can
I'm
share
Ma'am,
your screen,
kindly
madam.
share your screen, ma'am.
And
1 minute, ma'am.
Okay.
Is visible, ma'am?
Yes, ma'am. Yes, ma'am. Make it as full screen.
Okay. Full screen. Now, okay, ma'am.
Yes, you can proceed now. Yes, yes. You can proceed.
So I'm going to present on the topic of on SP numbers. This is outline now. My paper. So introduction. The paper of this. The purpose of this paper is to characterize a finite set of natural numbers whose sum and product are same. That is to investigate the natural number of solutions of the equation x1 plus x2 up to xk equal to x1 cross x2 up to xk, using which the notion SP numbers are introduced and characterized. In this paper, I am going to introduce a novel of SP numbers and characterize of it. This paper of work is, I am going to explain a novel SP number, and there is no existing work related to SP numbers. So this paper deals with the positive integer solution of the following equations. The sum of the numbers equal to product of the numbers, sum of the numbers which is greater than product of the numbers, sum of the numbers which is less than strictly less than product of the numbers. Such solutions motivate to define and characterize the notion of SP numbers. The relation 1.1, 1.2, and 1.3 are meaningful as for k equal to 3. The numbers 1, 2, 3 satisfy the equation 1.1. The numbers 1, 2, 2 satisfy the equation 1.2, and the numbers 1, 2, 4 satisfy the equation 1.3. This was these equations with the natural numbers variables are discussed in the second section, and the third section deals with HB numbers. Throughout this paper, capital A denote the set of our natural numbers a, b, k, m, n, and a1 to ak and b1 to bk are all natural numbers unless otherwise specified. Some problem existing approaches. Equation with the natural numbers variables. The following lemma will be useful to classify the solution. Classify the solution of equation number 1.1, 1.2, and 1.3. Lemma: if a1, a2 up to ak is a positive integer solution of equation number 1.1, 1.2, and 1.3 respectively, then any permutation of a1, a2 up to ak is also a solution of equation number 1.1, 1.2, and 1.3 respectively. Next proportion, for k equal to 1, every natural number is a solution of equation number 1.1, 1.2, and 1.3 do not have a solution in n. Next proportion, for k equal to 2, equation number 1.1 has exactly one solution in n. The pairs 1, a2 and a1, 1 are the only solution of equation number 1.2. The pairs 1 plus a, 1 plus b with a, b belongs to n cross n are the only solution of equation number 1.3. Next proportion, for k equal to 3, equation number 1.1 has exactly 6 solutions in n. Equation number 1.2 has countable number of solutions in n, namely 1, 1, a, a3, and 1, a2, 1, and a1, 1, 1, and 1, 2, 2, and 2, 1, 2, and 2, 2, 1. Next, equation number 1.3 has countable number of solutions in n, namely 1, 1 plus a, 1 plus b, and 1 plus a, 1, 1 plus b, and 1 plus a, 1 plus b, 1, with the AB is strictly greater than 2. 1 plus x, 1 plus y, 1 plus z with x, y belongs to n cross 3. Next proportion. For any integer k is greater than 3, equation number 1.1 has countable number of solution in n. Equation number 1.2 has countable number of solution in 3, and also equation number 1.3 has a countable number of solution in n. Next. I'm going to introduce about SP numbers. The definition of SP number is the number m is a SP number of size k if there is a k tuple a1, a2 up to ak of natural numbers such that m equal to summation taking one at a time equal to product, holds that is m equal to sum equal to product. This table demonstrate about the SP numbers. From the above table, we infer that 4 is a SP number of size 2 associated with the pair 2, 2. Because of, if you add 2 plus 2, we can get 4, which is equal to product 2, 2 also 4. So that we are telling 4 is a SP number. Like that, 6 is a SP number of size 3 associated with the triplet. If you take summation 1 plus 2 plus 3 is 6, which is equal to product 1 into 2 into 3, which this value is also 6. So that we are telling 6 is a SP number. Like that, 8 is a SP number, 9 is a SP number, 10 is a SP number, 12 is a SP number, 14 is a SP number, 15, 16, 18, 20 is also a SP number. Next proportion. Let k is greater than 3 and k minus 1 be prime, then m equal to take 2k is a SP number of size k. Proof, since k minus 1 is prime, its only factors are 1 and k minus 1. We take a equal to 1 and b equal to k minus 1. In the concluding remarks, already we have given in proportion 2.3 as k plus a plus b equal to k plus 1 plus k minus 1, which is equal to 2k, which means m equal to 2k is a SP number of size k. Next proportion, for any natural number k, 2 into k plus 1 is a SP number of size k plus 1. And every even number m is greater than, strictly greater than 4 is a SP number of size m minus 2. Proof, taking a1 equal to a2 up to ak minus 1 value is 1 and ak equal to 2 and k plus 1 equal to k plus 1. We have summation taking one at a time, a1 plus a2 plus up to ak plus 1 value is k minus 1 plus 2 plus k plus 1 equal to 2 into k plus 1. By taking k equal to 1, 2, 3, 4, 5, 6 and so on. In the first part, we see that 4, 6, 8, 10, 12, 14 are product equal to a1 cross a2 up to ak plus 1 equal to 1 into 1 into 1 into 2 into k plus 1 equal to 2 into k plus 1. This proves the first part of the SP numbers of size 2, 3, 4, 5, 6, 7 and respectively. This proves the proportion. Next proportion, every even number which is greater than or equal to 4 is a SP number of size m divided by 2. Proof, let m equal to 2 into n plus 1, where n is greater than or equal to 1. By taking k equal to n in proportion 3.5, we see that 2 into k plus 1 equal to 2 into n plus 1, which is equal to m, is a SP number of size k plus 1, which is equal to n plus 1 equal to m by 2. Next proportion, If M is a SP number of size K is greater than 3, such that K minus 1 has exactly 2 proper factors, then M equal to 2K or K plus 1, which is strictly less than M, strictly less than 3K minus 2. Proof, let M be a SP number of size K is greater than 3, such that K minus 1 has exactly 2 proper factors, namely A comma B, then 1 comma K minus 1 comma A comma B are the only factors of K minus 1 factors. 1, K minus contributes the SP numbers 2K of size K and the factors A comma B contribute the SP numbers K plus A plus B of size K, then M equal to 2K or M equal to K plus AB. If M equal to K plus A plus B, then K plus 2, which is strictly less than K plus A plus B, which is strictly less than K plus K minus 1 plus K minus 1, which value equal to 3K minus 2. This proves the proportion. Next proportion, let K be a number. Then if K minus 1 is an ideal number of size 3, the triplet X comma Y comma Z, then K plus X plus Y plus Z is a SP number of size K. If K minus 1 is an ideal number of size 4 with 4 tuple W comma X comma Y comma Z, then K plus W plus Z plus W X plus Y plus Z is a SP number of size K. Next, if K minus 1 is an ideal number of size K with K tuple P1, P2 up to Pk, then K plus P1 plus P2 up to Pk is a SP number of size K. Then conclusion and future work. Natural number solutions of the equation x1, x2 up to xk equal to x1 cross x2 up to xk are excluded. Some special types of natural numbers, namely an ideal number and SP numbers, are investigated. Combinatorial and topological properties of the newly defined numbers may be further characterized. So my paper has applications to construct the finite topological spaces, finite binary topological spaces, and finite n-ary topological spaces. These are my references. Thank you.
Madam, Dr. Sita Lakshmi, madam.
Yes, sir.
So where do you get this basic idea SP number? Where it evolves?
Already I have used in my the project in doctoral thesis. I have used 3 tuple numbers for the purpose of
SP means some product numbers.
sum equal to product. So that
Sum equal to product numbers.
product.
So that
So
we
that
call it as
it's
SP numbers.
SP numbers.
But now we are using only for the natural numbers. Natural numbers means it starts from 1, 2. That's only you are taking only for the positive number,
Yes, sir.
positive integers, right?
Yes, sir.
Okay. So what is the basic idea or what is the basic topological structure based on this SP numbers? Because we are giving that sum x1 to xn is equals to x1 to xn, that sum equals to product, right? Sum
Yes,
of n
sir.
numbers equals to
Sir,
the product of n numbers. You are telling
yes,
that,
sir.
right?
Yes, sir.
So and
Yes.
then you are giving some examples for that, right?
Yes.
But one thing, if you want to prove it in anything in general,
Uh,
right?
yes, sir.
So you are telling in your very first slide, that is, you are. Can you go for your third or fourth slide? There
Yes,
you
sir.
put
Yes, sir.
equals
Sure.
to. Here, next slide.
Yes, sir. This one.
Here you're putting 1.1, 1.2, and 1.3,
Yes,
right?
sir.
But for you, SP numbers means it should satisfy 1.1. It's
Yes,
clear?
sir. Yes, sir.
Not 1.2 or 1.3.
Yes, sir. Yes, sir.
It's only 1.1, right?
Remaining equations which are used to define the binary and n-ary topologies. In binary and
I'm
n-ary
asking
topologies.
if
Yes,
your
sir.
number is SP number means it should
Yes.
satisfy 1.1.
Yes, sir. Yes, sir.
Nothing that. No, because it's 1.2 and 1.3 started coming into the picture
Yes,
when you
sir.
talk about SP numbers, because
Yes, sir.
sum should be equals to product, right, madam? So all
Yes,
your
sir.
A, B, K, M, and all are only natural numbers only, madam.
Yes, sir.
All
All are
A, B,
natural,
K, all are
all
your
are
A, B,
natural numbers.
only natural numbers. Only
Yes,
start
sir.
from 1 to infinity.
Yes, sir.
Okay, right.
Because of, to define the power sets in topology, only we are taking and the examples
Okay.
we are taking
Okay. So now you're
natural
going.
numbers.
Okay. Now you are doing some next. You can go for next slide, madam. Next slide. Next.
Yes, sir.
Next slide. You can go for next slide. So
Yes,
here
sir.
you are telling say no, proportion 1.2.1 before one. Before
Proportion.
one. Next before slide. Before slide. Here you are putting A1 A2 dot is a positive integer solution.
Positive integer solutions. Yes, sir.
It's a positive integer solution of
Solutions.
1.1.
Solution is only we are taking natural numbers. The solution is integers maybe
Because positive integer means
only.
it's a natural numbers you are telling because that is a
Yes,
positive
sir.
integer.
Yes, sir. Yes, sir.
And you are telling solution of 1.1, 1.1, 1.3 respectively. Then what is the meaning of? Because I'm asking, it's a solution of 1.1, 1.2, 1.3. Then it's a solution of, then any permutation is also a solution of 1.2, 1.3. Because here because you are only talking about 1.1. That is your SP number,
Yes,
right?
sir.
And
Yes, sir.
then why you incorporate 1.1, 1.3?
Suppose the numbers may be greater than or less than.
Okay, that is always happen, madam. That is always happen. But we are
So
only
that I'm
talking.
taking. Sometimes it will be results may be
because
failure.
no. Because we want to equate it because we go your lemma, your proportion.
Yes,
Go
sir.
for 3.7. You can go for 3.7 before this. 3.3 is there.
3.7.
Okay, so
Yes, sir.
before 3.6 you go, madam. In 3.6,
6.
there you put in the last line
Yes,
k
sir.
plus a plus b. If m equals to k plus a plus b, then k plus 2 is strictly less than k plus a plus b. But you already told a and b are natural numbers,
Yes,
right?
sir.
So
Yes, sir.
a and b at least it should be 1 or greater
Mm.
than 1. A and b should be at least should be 1 or greater than 1. So
Mm.
in such a case, if a and b you take it as 1 and 1, then
Mm.
k plus 2 is not 60 less than k plus 2.
Only we are taking k is greater than 3, strictly greater than 3. So that.
No. You're
Yes, sir.
telling k plus 2 strictly less than k plus a plus b.
Yes,
We
sir.
can take a plus b as 1 and 1 because we can't take less than 1 because you are taking only on natural numbers. So the least number that a and b can take is only 1 and 1. So
Yes,
if you
sir.
take a equals to 1 and b equals to 1,
Mm.
right? In
Yes, sir.
how k plus 2 is strictly less than k plus 2?
We are taking k is strictly greater than 3.
No, we are not.
Suppose
K may be anything, madam. K may be
yes, sir.
anything. K may be
Yes,
anything.
sir.
Plus 2 is there, right?
Mm.
Plus 2 is there, and which is strictly
Understood.
less
Understood.
than which is strictly
If you put a equal to a equal to 1 and b equal to 1, in this case it will be equal.
that one I am asking. But you are putting a
Less than or
strictly less
equal to.
than.
Here I forgot to put a less than or equal to.
It may be equal to, or the right hand side may be more than.
Yes, sir.
Then in that case, the next inequality also may be less than or equal to will come.
Yes, sir.
So that I'm asking because wherever you put, you are putting strictly less than or
Yes,
strictly
yes.
greater than.
Yes,
But whenever we come to your SP numbers,
yes,
right?
sir.
Because here you are finally proving k plus 2 is strictly less than 3k plus minus 2, something you are putting, right? And you're
Yes, sir.
putting that m should be in between k plus 2 and 3k minus 2, right?
Yes, sir.
With that. But what I'm asking, right? What is the idea behind SP numbers? It's only for equality or for inequalities?
The numbers which are equal.
Only for equalities.
Equals.
Only for equalities.
Yes, sir.
The only thing, madam, you have to first you specify the basic idea of
Yes.
what is a k number because you are tell k number because when you show your examples, no, can you go for your examples?
Which one, sir?
Previous examples. You put numbers, no, madam.
Yes, sir. Yes, sir. Which one?
Here you put k is a SP number of size 2.
Yes, sir.
Right? So then 6 is the SP number. So 6
Yes,
is the
sir.
SP number means you can get 6 as a solution. 6 as
Yes.
a solution. When you add 1 plus 2 plus 3 is 6, as well as 1 into 2 into 3 is also 6. So you have to define SP number means 6. Size means 3. Then that size represents the length of the numbers. Now the sum of the numbers having 3 tuples. Okay,
Yes,
so
sir.
that you have to define in a proper manner. That one thing. And one more thing, whether you when you show your 4 tuple, 5 tuple, and next slide also can go. Next slide also, or
Yes, sir.
previous slide. Okay, right. So it always there's one pattern is there, madam, here, because whenever we take, if you want to show something into something, some multiplication, we always need only two numbers, and we can safely take the previous numbers as 1 plus 1 plus plus 1, but because even if you look at your own examples, from 12 is SP number or 20 is SP number, right? All
Yes, sir.
your, when you take an n tuple number, you can
Yes,
take
sir.
up to n minus 1 and n, you can take it as your own, right?
Yes, sir.
As you like. And then the remaining thing, you can simply make it as 1 1 1 1. So in that case, that you are, if in n tuplet, there are n minus 2 numbers already fixed as ones. Only your last two digits are changing.
Yes, sir.
So in that case, you can fix your theorem in such a case that, right? Because the only one will work in that case. Then how
Yes,
can
sir.
you tell in for any number? Because you are in, when you start the thing, you tell a1 comma a1 plus a2 plus a3 plus an is equals to a1 into a2 into a3 up to an. But for that an, except the last two digits, most of the times you have to only assume for one only. Then how can you prove it in general?
We can replace the numbers
No,
instead
we
of
can't
one.
replace. We can't replace. Because I know one thing, because we take a 10 tuple, right?
Yes, sir.
If you add 10 plus 2, then the remaining 8 numbers, you
Yes, sir.
make it as, then automatically 10 plus 2 is 12, 12 plus 8 is 20, right? And
Yes,
when
sir.
you multiply, automatically you multiply all the 8 numbers, you will get only 1. So you can simply fix the last two digits as your SP number is 20. You can fix 2 into 10, 20, and remaining numbers you just, in the summation, out of how many numbers, suppose, no, if in 10 plus 2 is 12, 10 into 2 is 20, then you can easily make, okay, 10 plus 2 is 12, 10 into 2 is 20, so we need 8 more numbers, so we can make a 8 triplet,
Yes,
or
sir.
8 numbers, then we can easily solve. So that coming through a trial and error process, not by a theorem. Because because we want, suppose if you have 30, then we can say 3 into 10 is 30, 3 plus 10 is 13. So we can make a 17 numbers, 17 ones we can add, the 17, 18, 19 numbers. So we can make a 19 size associated numbers. The 19 numbers, 17 numbers are 1, and last two digits are 3 and 10. So the sum will be 30, and multiplication also 1 into 1 into 1 up to 17 numbers. Then 18 the number is 3 and 19 number is 10. I can fix with ones and tens. I can change only the n minus 1 number. I can change only one number, and I can do it for all numbers. Whenever it is a even number. For prime numbers, we can't do, because prime number is not possible. But all non-prime numbers, we
Yes,
can
sir.
fix once, and we fix 10 or number, and only we can change only because it has only 1 degree of freedom.
Okay,
Even
sir.
you tell n triplet, but it has only a 1 degree of freedom.
Yes,
Other
sir.
things you can automatically fix. Even if
Okay.
you say 18, right? So
Yes,
18
sir.
means 9 into 2, 18. 9
Yes,
plus
sir.
2 is 11.
Yes,
So
sir.
11 means the remaining you need 7 numbers. So you can
Oh,
make as 9 tuple. So
yes,
7
sir.
ones and 2 and 9.
Yes, sir. Good idea, sir.
This is, you can do it by a trial and error method, or you can make a systematic thing. But how can you incorporate into a proposition? Because in proposition it is not there, because in proposition the proportion is entirely different. But when you see the examples,
Yes, sir.
it's quite naturally comes. You can fix once, only 1 or 2 numbers you can change, and you can get a SP number for any number. Even if you take 1000, right? We can
Yes, sir.
up to 998, we can mix 1 1 1 1 1, and we can only fix the last two numbers, and you can get it 1000 also. So that I'm asking.
Okay, sir. Thank you, sir.
Yeah? Madam,
Okay.
Tamil madam, if you want to ask, you can ask.
Sir, as sir said, madam, you just take some of the examples or do the things, vary the AIs, A1, A2, etc., AK, instead of taking only the last two elements. Try to work out all those things. Anyway, Congratulations. But try to give the reference also. Which you are saying that SP number you have defined already in your paper and so thing. Try to give
This
the references.
just to only this is all
You
my
did.
own papers. Ma'am.
Anyway, you have to show, right? That's why I'm asking. Yes, ma'am. You did show that earlier. That's why I'm asking. Okay. Okay, ma'am.
Okay, thank you, ma'am.
Follow the instructions, whatever sir said. Okay.
Leave it.
Next person, ma'am.
Okay. Next presenter, Dr. Nisha E. Nisha ma'am, are you there?
Yes, sir. Yes, please.
Okay, ma'am, you can finish.
Yeah, sure. Is it visible?
Yes, ma'am.
Yeah. So good afternoon to everyone present here. So I'm Dr. Nisha from Rajalakshmi Institute of Technology. I'm going to present a paper on the topic titled Study of Volume Rate, Shear Stress and Shear Force on Finite Width Journal Bearing with Micropolar Fluid. So many researchers, outline of the paper includes the introductions and the mathematical formulations, assumptions which I have made in my paper, methodology used, some of the results and discussions, conclusions and future work, and some of the references I have used here. So many researchers like Chandan Singh and Konsari, they have already studied micropolar to an extent that they have already found it out the velocity distributions, micro rotation velocity, and workload resulting in increased width and respect to material characteristic and the coupling number. So my papers, so mostly the micropolar fluid papers, typically it addresses how the fluid respond to various forces. So I have used here some of the aspects of fluid dynamics such as turbulence so that it will differ some of the factors like in terms of theoretical framework. So for basically, I have used here the hydrodynamic journal bearings. So journal bearing is nothing but a type of a sliding contact bearing that supports a rotating shaft. I have used here the micropolar fluid. Micropolar fluid is nothing but the complex fluid consists of microstructures elements. So I have already used many of the fluids such as coupled stress fluids and Casson fluids for my papers. This is different because I am using here the microstructure elements, which actually differs from other fluids in such a way that we know that in for hydrodynamic bearings, work smoothly without tear and wear and frictions, we need a very compatible lubricant so that it can be present in the collar and in the journal surfaces so that the lubricant should cool down the surfaces and the bearing system will work perfectly without any kind of frictions. So I have used here the lubricants micropolar fluid so that the microstructures will make the lubricants more smoothly. It will lead the lubricants to work more smoothly. It will occupy all the places, all the surfaces so that there won't be having any frictions and wears. So basically, if I'm going through my topic, that is a study of volume rate, shear stress, and shear force. So before I go inside my paper, I need to tell what is shear force, what is shear stress. So volume rate, we all know how the fluid flow is going out, the rate at which the flow is happening. Shear force is nothing but the internal force that acts parallel to the surface or cross section of material. And shear stress is the intensity of the shear force, how the force is acting on the surfaces. So I'll be studying here all these elements and seeing how whether the micropolar fluid is acting perfectly on the bearing systems or we have to work on the lubricants. So these are the general configurations of my bearing here. You can see the configurations here. I have used the capital U as a top velocity in x directions. A is the plate dimensions. H is the film thickness and capital W is the workload, which is acting from the top. Why it is acting from the top? Because the lubricant is a microstructure, so the most of the load will be applying on the top surfaces. So this is my configuration. So according to this, these are the assumptions which I have made. The flow will be laminar. The flow film's curvature can be disregarded because it is already thin enough in relation to the bearing length and span. Bearing surfaces are free of slide, and these are the pre-assumptions which I have made because of the previous researchers' studies. So there is no surface roughness, that is the bearing surfaces are smooth. The surface of bearings are impervious. The bearing surfaces are not distorted by the fluid stream pressure. Because of the previous researchers, they have already made this study and they have studied there. If there is a impact of surface roughness in this paper, in this study, then definitely the flow rate will be very, very high, which will make the surfaces to tear it up, or will make the surfaces to create a wear on that. These are the physical representation of the width journal bearing. So since this is a hydrodynamic lubrication, so I have taken the generalized lubrication equations. So from this, I will be finding out the continuity equations and I'll solve and I'll find out all the parameters. So I have taken typically this equations, the equations which you are seeing in the screen. These are the equations I have taken for my width journal bearing, because it satisfies all my pre-assumptions. So these are the terms which I have been used in the previous equations. So here I have already non-dimensionalized it. Non-dimensionalizations will make the equations to solve very much easier using or any numerical method. So what we will be doing in the non-dimensionalization is that we will be discarded some of the factors which is not influencing the bearing systems. So after non-dimensionalizations, I have got these equations. Boundary conditions, I have used it here. And these boundary conditions I have got it from the Reynolds equations from the hydrodynamic lubrications by Hamrock. So I have to find the volume rate. So these are the volume rates which I have got it. The attitude angle I have made it. I have got it, and these are the shear stress acting on the solid surfaces. So every equations is already present. I have solved it using the numerical methods, using the MATLAB. These are the shear forces. So I'm using for both the surfaces, the lower surfaces, that's why I have mentioned z equal to 0, and for the upper surfaces, z equal to h. So that for both the surfaces, I'm finding it out because I'm using it here, the diameter ratios. So we have two diameters here in the bearing system. So that's the reasons I just wanted to know how the differentiation will make the bearing system to work. So these are the variations of a volume rate with respect to height with different width diameter bearing ratio. So here we can able to find it that volume flow rate with respect to height with diameter ratio increases with the diameter ratio leads to increase in volume rate. Why it is increasing? Because of the difference between the two diameter. Because of that, it reduces and causing the smoother transition of lowering pressure loss. Because of the smooth transition, pressure loss is very much low, and it will lead to effective flow rate. This is figure 4, which is showing the variation of volume rate with respect to attitude angle with different height values. So volume rate with respect to attitude angle, it approaches volume flow rate. It helps to maintain the proper lubrications even there is a change in attitude angle. Even when we change the attitude angle to some extent, it will be working out because of the volume flow rate is high in this bearing system. Figure 5 demonstrate the variations of shear force on upper surface with respect to attitude angle with different value of viscosity. So I have used here a different parameter, that is the viscosity, so that I can able to find much more difference how the bearing system is working with this micropolar. So here we can see that the shear force with respect to attitude angle with viscosity. Viscosity is nothing but it is a measure of fluid's resistance to flow. Since our flow rate is very much high, that's why I have used the viscosity parameter. If we are including the viscosity, how the bearing system will work, whether it will be working slowly or there will not be any effect in the bearing system. So figure 6 depicts the variation of shear force on lower surface with respect to attitude angle with different value of viscosity. So shear force with respect to height increases due to more accurate force at higher sections. Since the workload is from the upper directions, so the workload is more in the upper places. That's the only reason the shear force is decreasing with respect to height. So these are the conclusions. The physical parameters are all computed. Flow rate, flow volume rate, velocity, attitude angle, and shear force in upper and lower surface with respect to different parameters have been find it out. Parameters like attitude angle and micropolar fluid parameter also have an impact on physical quantities. It is observed that by increasing the height of the width bearing, the maximum pressure in the bearing will face an extreme decrease, and also by increasing the height and attitude angle, the rate of volumetric flow rate will decrease. So I have already shown that because of the attitude angle and height, our volumetric flow rate is increasing. So sometimes it will increase into such an extent that we cannot be able to foresee it. So because of that, we can even change the attitude angle and height in such a variation. So I have taken here 0 to 1. So if you are increasing from extent to 1, then how the volumetric flow rate will happen, how the transition will happen? Definitely it will decrease, because that studies have already been made by the other researchers. These are the references which I have used. So most of my paper logic is from the 1 and 2. Most of the ideas I have got it from 1 and 2. These are the future work which I'm just presuming to do now. I'll be doing the computational fluid dynamic simulations method here. I'll be using the AI-based predictive models here, optimization technique, because some of the errors I have found it out while doing the paper. So I can optimize the errors to some extent using some statistical methods and investigate the impact of smart materials or surface coatings. I have already told I have not taken any surface roughness parameter here, but some of the surface roughness parameter, if I'm using how the bearing efficiency will be, that will be my future. Thank you so much.
Madam Dr. Nisha, madam.
Yes, sir.
So, so you are working on this particular area, right?
Yes,
So
sir.
can you
Fluid
tell
dynamics.
me any applications of this where we can use? Because it is there that because it is there in so applications so many places, but where particularly we can use this your findings?
The micropolar fluid, sir,
No,
in journal bearing,
in
right?
general, in a real life, where we can apply this.
In real life.
Hmm. Because we made some assumptions in the
Yes,
beginning
yes,
itself,
sir.
right? So why you make
Yes,
that
sir.
assumptions? Because if you made
So
some assumptions,
uh,
because on certain conditions we have to make some assumptions. So if certain conditions arise, only if you work on some particular thing, right? Suppose we work on only on particular thing, suppose for only for automobile or only for
yes, sir.
then we can make some assumptions because it has some restrictions.
Yes, sir. Yes, sir.
So why you make that assumptions and where exactly you can we can apply your idea?
Sir, I have made the assumptions because it was not tallying with my bearing system, sir.
No,
If
no,
I'm
you
not
can,
making,
madam,
uh,
whenever we make assumptions, the assumptions has some meaning, right? We can't assume everything in any
yes,
method
sir.
because
Yeah,
if you
I
want to prove
understood.
certain things, right? We can't tell, okay, this not coming with my solution, so I assume this will be like this. But you can't assume because if you assume certain things, then physically it has a meaning. Okay, physically, suppose the gravity is there. So for Earth, gravity is only 9.8. So you can assume that gravity is 9.8, right? So that type of assumption can be
Yes, sir.
made only on certain conditions, but you can't assume yourself certain things. Oh, these are the things should be there. Then it will won't work in a real life because in real life, when you do something, right, you can't ensure
Yes,
that
sir.
all these assumptions are already there in that particular application. So you should specifically tell one thing. And one more thing, when you show your solution procedure, which type of methodology, numerical methodology you apply? Because you
Sir, I
used
have used trapezoidal one-third rule, sir, in numerical using the MATLAB program, sir.
That you have to tell, madam, because that is the mathematical part. Because whatever you are telling is most of the things are only related with physics or engineering, right?
Yes, sir.
But we
Yes, sir.
need the mathematical part where you work. That
The
because that is the because that is
trapezoidal rule I have used, sir.
because whenever you work on mathematics, right? We assume certain things. Mathematics can't
Yes, sir.
assume
Yes.
because when we assume something in mathematics, it has some meaning physically. So that one I am asking. So whenever you work on mathematics, then only you can know why you assume this and why you are doing this. And when you show one of your PPT that lower and higher ZH or Z0 and ZH one
Yes, sir. The boundary
integral
conditions.
the boundary conditions uh, can you show that integration, madam? Integral.
Yes, sir.
No, this not one. You just put equal to zero. Put one thing. Uh, can you?
This one.
No, no, no. This one, because here you put FB, and why it comes as zero in the right hand side?
So the equation is like that, sir. We will be assuming FA equal to 0, the lower side,
Uh,
and also and we will be checking that the results, how it is coming, sir. It
because
is coming
there when
positive or not.
if you assume this thing, right? So in the in between we have
Uh,
integral minus theta by 2 to plus theta by 2, and we have integrand and dx, right? So whenever in a very basic integration rule, minus a to a f of x dx equals to 0 means the function should be a odd function. Is there anything like that? Is
yes,
there?
yes. No, sir, no, sir. All the papers are based
No, no,
on
no.
the
Because
previous studies, sir. So what they have mentioned, they
no,
have
no, madam. Here, if
pre-assumed.
this thing comes, because you put b in both the equations. So if some b to that integral value equal to 0 means if product of two things is equals to 0 means any one of them should be 0. If b cannot be 0 means then in minus by 2, then theta by 2 of zx dx should be 0,
Okay,
right?
okay.
Because the
Yes, sir.
product of
Yes, sir.
two things
Yes, sir.
equal to. If that is 0
I'll.
means, if integral of
Uh,
that value is 0 means, then automatically tau of zx should be a odd function.
yes, true, sir. True.
Whether so there only the real application parts is coming. So the
Artists.
function
Yeah.
should be
Yes, sir.
a odd function. So if your odd function means, what is the meaning of that in real life or real applications?
So I have to go through it, sir, because
Uh,
I've not
uh,
seen this conditions
because
properly.
the
I'll be.
conditions because in the
Yeah.
condition shows whether it is z at 0 or z at h, that the integrand should be a odd function.
Yes, sir.
It should
Odd
be a
functions.
odd
Correct.
function. Then only minus a to plus a of that f of x dx is equals to 0. So that b into that value is equals to
Zero.
0.
Either or.
Okay.
Yes, sir.
Because
Correct.
mathematical part we expect more, madam. Because that only
Fine, fine, sir.
because most of the physical things we also don't know, right? Only people good in fluid dynamics knows all the definition and other things. But where how we work mathematically there
Yes, yes.
and
True,
what
sir.
are the assumptions we made, okay, that should have some basic mathematical conditions, because only some basic mathematical conditions only force us to make that some assumptions. We can't assume ourselves because that in theorem we have to prove this. So if you assume like this, we can prove like this. That cannot be done. That
Okay,
can be
okay,
done
sir. Fine.
only
I'll
when
take
if you
care.
have a mathematical background for that.
Sure,
Okay,
sure, sir. I'll
okay.
take care of that,
Thanks,
sir.
sir. Thanks, sir.
Thank you, sir.
As that, if you follow that, then you can create some more results also.
Sure, ma'am. Sure,
Change
I'll
the
work on that.
values, how it will be. You have to follow that. Otherwise, all the other things are good. Nice, ma'am.
Thank you so much, ma'am. Thank you. Thank you, sir.
Thanks.
Next person, ma'am.
Next presenter, Miss M. Menaka. Ma'am, are you ready?
Yes,
Menaka,
ma'am.
ma'am.
Yes,
Okay.
ma'am.
Kindly share your PPT, ma'am.
Is it visible, ma'am?
Yes, ma'am. You make it as a full screen, ma'am.
Okay. Ma'am, can you see my screen, ma'am?
Yes, ma'am. You can continue.
After all, I am M. Menaka, research scholar in SRM Institute of Science and Technology. These are my outlines. Introduction, mathematical formulation, problems in existing approaches, proposed methodology, conclusion and future network, and reference. So first introduction. So mathematical modeling is the process of converting real life issues from one application field into tractable mathematical formulation. Dynamical systems, statistical models, differential equations, and game theoretical models are only a few examples of mathematical models. A model aids in the explanation of a system, the study of the impacts of various components, and the prediction of behavior. It can be analyzed theoretically and numerically to provide the solutions and important guidance to the original applications. However, nonlinear differential equations are generally too difficult to solve using standard analytical methods. So my work mathematical formulation. Consider a longitudinal fin with a constant rectangular profile, section area capital A and length capital L, perimeter capital P, thermal conductivity K, and the heat generation Q star. Fin is attached to the surface with a constant temperature TB and losses heat to surrounding the medium with the temperature T infinity through a constant convective heat transfer coefficient H. In the problem, we assume that the temperature variation in the transfer direction is negligible. So heat conduction occur only in the longitudinal direction, that is x direction. So the differential equation for the present problem may be expressed d square T capital T divided by dx square minus HP by K naught A, T minus T naught plus Q star divided by K naught equal to 0. The boundary conditions are at the initial x equal to 0, dt by dx equal to 0, at x equal to L, T equal to TB. So fin with the temperature dependent internal heat generation and thermal conductivity. Assuming this case, the thermal conductivity of the fin to vary linearly with the temperature. So we have K by K naught equal to 1 plus beta TB minus T naught T infinity equal to 1 plus epsilon C. So the governing differential equation in this case becomes d by dx of 1 plus epsilon C theta of x, d theta of x by dx minus n square theta of x plus n square g 1 plus epsilon g theta of x equal to 0. The boundary condition are x equal to 0, d theta of x by dx equal to 0, and at x equal to 1, theta of x equal to 1. So in the same nonlinear equation, already Ananthaswamy editorial used to Ananthaswamy Sivasankari method to solve the equation 5 with the boundary condition 6 and 7. They obtain the analytical expression theta of x equal to cos h x cos h ax divided by cos h a, where a equal to square root of n square into 1 minus g 1 plus epsilon g. As this editorial used optimal linearization method to solve the equation 5 with the boundary condition 6 and 7. They obtain the analytical solution theta of x equal to g plus 1 minus g cos h n1x divided by cos h n1, where n1 equal to n into 1 minus epsilon g into capital G, 1 plus 2g sin h 2n divided by 1 minus g 2n plus sin h 2n, the whole power 1 by 2. But my work is many analytical techniques concentrate on developing an analytical solution of nonlinear differential equation. The Taylor series expansion method is developed as a suitable high precision method for solving such problems. Here we applied the Taylor series method to solve the nonlinear equation 5. We get the result 1 equal to theta of 0 plus theta, the second derivative of 0, 1 by 2 factorial, theta fourth derivative of 0, 1 by 4 factorial, plus theta of sixth derivative of 0, 1 by 6 factorial. So the conclusion of my work is the analytical simplicity, even when the new internal heat production and thermal conductivity rise at the base from their values at the sink temperature, the solutions still match numerical data with the maximum error of 1%. So previous result, they were getting more than 10. So in Taylor series method, I will get I got the 1% minimum error. Given its remarkable accuracy, we may draw the conclusion that This approach might be great substitute for existing approach for addressing the boundary value issues with signal nonlinearities. These are my reference papers. Sir, any questions? Ma'am?
Manaka madam,
Sir?
you can go to your second slide. So these are
This
your this is your mathematical formulation.
formulation, sir.
Formulation.
Sir.
So your thing is you have a differential equation in one and you have a boundary conditions on
Yes.
2 and 3, right?
Yes, sir. Yes, sir.
Okay, right. So then you move on to the next one, madam. So okay, so this your assumption, right? So next thing you told some results you are getting. So next slide you can go.
Dimensional, we have to reduce the dimensional
No,
equation.
next slide you can go. Next slide. You have shown some previous results, right?
Yes, sir. Yes, sir.
So now you are using your Taylor series methodology.
Yes, sir.
You are up to solve the differential equation with the
yes, sir.
with the boundary conditions, right?
Yes,
so so how your result is
yes.
differ from the previous result? Because in previous result, which type of methodology they used?
Ananthaswamy Sivasankari method and optimal linearization method, sir.
There
are two methods.
Which because you are using Taylor series methodology.
Yes, sir.
Right,
yes,
for
sir.
solving a differential equation, that is ordinary differential equation with boundary conditions, right?
Yes,
so but in previous ideas, what they used, because you are quoting them, right? Previous results.
Yes, sir.
So
yes,
in
sir.
previous results, what they done and how the Taylor series methodology is much better than their methodology.
These results, Taylor series results, are nearly to numerical results, sir.
Right.
I got semi-analytical method, but nearly to numerical results, sir.
So where you shown, because mathematically, how you proved, because you are you go to the next slide, because this is your methodology. Taylor series methodology is your methodology, right?
Yes,
then
sir. Yes,
then
sir.
we will exactly know how you proved this methodology is much better than the previous one. That work procedure should be done, no, madam.
That work table, sir, I won't touch.
That you have to tell, no, madam. Because
Yes,
how previously you quote some people, right? So
yes,
they
sir.
also
Yes,
done
sir.
certain things.
Yes,
But
sir.
now you are using Taylor series methodology. But not only Taylor series,
Yes,
we
sir.
have a Rangigutta method is there, RK method is there to solve a differential equation with boundary conditions. So
Yes,
for
sir.
me, RK method is much better than Taylor series method. Then why can't you use RK method instead of Taylor series method?
Okay, sir.
Because you know, madam, because the in general we know in numerical methods, right? Taylor series method, then we RK method, right? Rangigutta method is much better option when you solve a differential equation. So that I'm asking why you choose Taylor series method. Suppose we choose Taylor series method means the previous methods, whatever the
okay.
no, simple is different, madam. Because if you need a solution with minimum error, error,
Yes, sir.
we
Yes,
need you have to adopt higher order numerical methods, because Taylor series is only a first order method, right? Rangigutta method is a fourth order method, right?
Yes,
so that
sir.
I'm asking, why you choose Taylor series method, because you're quoting previous people. Suppose if previous people use much slower method than Taylor series method, then you can use Taylor series method. That is one thing is there. But even if you use Taylor series method when solving a differential equation, but you have a very good Rangigutta method is there, so that I'm asking. So why you particularly choose that thing?
But I got results nearly to numerical values.
No,
sir.
that near numerical values that can be applied using Rangigutta method also. Much better method, solution, numerical solutions you will get when you apply RK method instead of Taylor series method. Because if you show that table, no, madam, then it will be clear. Because the table is missing. Because you straight away go to your conclusion. But if you show your work, right, how the Taylor series you applied and then how the numerical values you are getting is closer to your finite values through Taylor series. That if you should know, then that is a better
Okay,
one.
okay. I
Okay, madam.
can't
But
attach table
my
here,
suggestion,
sir.
but my suggestion
Okay.
is there are
Ah,
some higher order methods, right?
okay,
Then
sir.
even
Okay,
bigger
sir.
than
I will.
alchemy method also there, right?
Okay,
But we
okay,
need
sir.
so that you can do it, right?
Okay, sir.
Okay,
I will try, sir. I will
okay,
try that
okay,
method, sir.
okay, madam.
Thank you, sir.
How you are finding the solutions, whether you are using any softwares or you are doing only by manually?
By manual, sir, ma'am. For Taylor series, for one manual, ma'am. For numerical
Yes,
data,
if
I
you are
use
using,
MATLAB, ma'am. MATLAB program.
you can use the computations also in the thing, so that as I said, you can use all those methods and you can find the solutions and comparisons, everything you can give it.
Okay, ma'am.
Diagrammatically also you can try to use for
Oh,
solutions
okay, ma'am.
also try to find the used applications, MATLAB
Okay.
and whatever the software you know, you can proceed.
Okay,
Yes,
ma'am. Okay,
you
ma'am.
can use.
Okay.
Yes, ma'am.
Thank you, ma'am.
Next person, ma'am. Next person, ma'am.
Next presenter, Miss Vijayalakshmi MT. Vijayalakshmi ma'am, kindly share your PPT. Ma'am, your PPT is visible, ma'am. Ma'am, your voice is not audible, ma'am. You can start, ma'am.
Is there any problem, madam, with the access with the election, madam?
Ma'am, sir, our voice is not audible, ma'am.
On screen
Ma'am?
also is screen also it's only a previous screen is there. அவங்க presentation share பண்ணா கரெக்டா இருக்கும்.
Yes, sir. Slide is visible. Vijayalakshmi ma'am.
Madam, can we move on to the
Ma'am.
next person so that we can அவங்க வேணா suppose அவங்க ரெடி ஆயிட்டு வந்தாங்கன்னா நம்ம நடுவுல வேணா இது பண்ணிக்கலாம்.
Okay, sir.
Huh?
Vijayalakshmi ma'am, can you unmute in Zoom meet, ma'am? Okay, sir. Can we move to the next
ஆமா
person?
ஏன்னா அவங்களுக்கு ஏதோ ப்ராப்ளம் ஆடியபிள் ப்ராப்ளம் இருக்கு அதனால அவங்களுக்கு
Okay, sir.
you can go for Manishka.
Okay. Next presenter is Mr. Manish. Manish sir, are you ready?
Good afternoon, everyone.
Yes, sir, you can proceed.
My PPT is visible, ma'am.
Yes, sir.
And title of my paper is A Novel Fuzzy Entropy and Distance Measure with Application in Sustainable Renewable Energy Source Selection. And I'm a research scholar of Maharishi Markandeeswar University, Mulana, Ambala. This is the outline of my paper: abstract, literature review, basic definition, motivation and contribution, existing fuzzy entropies, new fuzzy entropy, new fuzzy distance measure, then modified Topsis method using suggested fuzzy entropy and distance measure, then case study, and after that conclusion. This is my abstract part. As the world transitions towards a low carbon economy, the selection of sustainable renewable energy has become a critical component of mitigating climate change, ensuring energy security, and promoting economic growth. With the increasing urgency to reduce greenhouse gas emission and dependence on fossil fuels, it is essential to evaluate and compare different renewable energy sources such as solar, wind, hydro, and biomass power to determine the most suitable option relative to various conflicting parameters such as cost, efficiency, scalability, energy density, and environmental impact. The selection of sustainable renewable energy source is a complex process. For this, opinions of experts regarding the performance of different sources relative to different criteria are taken into consideration. This paper presents a fuzzy decision-making method for the selection of suitable renewable energy source. A fuzzy set is a useful tool for handling ambiguity and uncertainty in real-world situation. Fuzzy entropy is used to calculate the degree of uncertainty related to a fuzzy set. Several existing fuzzy entropies have certain limitations, so a new fuzzy entropy is suggested in this paper, which overcome the limitations of existing measures. A new fuzzy distance measure is also suggested to calculate the distance between fuzzy sets. The supremacy of the suggested distance measure in pattern recognition is shown within the add of a numerical illustration. The aim of present study is to present an efficient solution by associating suggested entropy and distance measure with the Topsis method so as to improve the stability of the Topsis approach. In classical set theory and element, basically this literature review is aims to explain the fuzzy set. In classical set theory, an element either fully belongs to a set or does not belongs to a set. Either membership degree 0 or 1. However, many real world situation involves degree of membership that fall between these crisp boundaries. Anji ma'am. Yes, ma'am. Are you asking something, ma'am? Am I audible, ma'am?
Yes,
You
you
can
are
continue,
audible.
sir.
You can continue.
Yes,
But
sir.
Okay. Jade introduced the concept of fuzzy sets by taking membership and non-membership degree of an element. Application of fuzzy sets have been identified
ये
in many different
इसमें से
domains,
ऑडियो नहीं जा
including
रहा था
pattern.
सुनाई दे रहा है लेकिन ये तो कुछ भी नहीं जा रहा है
Vijayalakshmi ma'am, kindly mute your audio.
Ma'am, is there any problem?
इसमें
One
कुछ
second.
कैमरा का भी कुछ
You can continue, sir.
Mr. Manish, you can go for your application part
Yes.
because basic
Anji
definitions
ma'am.
we
Anji
know.
sir.
Okay, you can go for the
Okay.
application
Okay.
part.
Okay. This is literature review, sir.
Okay.
These are some definition related to fuzzy sets. This is my sir. Can I say something about this motivation and contribution part?
Okay, right. You can tell. You can tell.
Okay. Study of fuzzy entropy distance measure gave many beneficial results, but several entropies and distance measure given by different researchers give inaccurate results as for different fuzzy sets, a number of entropies compute the same amount of ambiguity. The sequence of linguistic variable was not satisfied by a number of entropies that were already in existence. When choosing the optimal option, criteria weights are crucial. Yet, several entropies calculate the same weights for different criteria. Existing distance and similarity measures compute the same distance of a fuzzy set from different fuzzy sets. On the basis of these motivations, the basic contribution of this paper is a novel fuzzy entropy is introduced. A novel novel fuzzy distance measure is introduced, a modified Topsis method is suggested using suggested entropy and distance measure. These are some existing entropies. Uh, I'm here to mention
Sir,
an
your voice is
important
not
point. De
clear.
Luca and Termini suggested the four axioms to be
Anisha,
set to become the value of entropy must be zero. Okay, ma'am. Now is clear. It's clear, ma'am.
Okay, right?
yes, sir.
Ma'am, and now my voice
Okay.
is clear.
Voice is clear,
Yes,
no
sir, yes,
problem.
sir.
Okay. And second property is maximality. Third is resolution, and fourth is similarity. These are some fuzzy entropy measure given by suggested by different researchers. Some defined entropies you are using parameters. Some defined entropies using log function. These are some entropies given by different researchers. But all of these entropies suggested by different researchers have certain limitations, which I have mentioned above. Now I have introduced a new fuzzy entropy based using sine function, 1 minus 1 by n summation of sine 2 membership minus 1 square or multiplied by pi by 2. This is the figure 1, which is represent the graphical representation of suggested fuzzy entropy. One side is membership degree, second part is non-membership degree, and y-axis represent one dimension represent the entropy. Second is this is my suggested distance measure using membership and non-membership of two degrees of two fuzzy sets. 2 raised to power minus membership of first fuzzy set minus 2 raised to power minus membership of degree of no second fuzzy sets plus second part. I have used this distance measure in pattern recognition problem. Pattern recognition problem is the process is to recognize the to categorize the uncertain pattern into recognized pattern. These are the three basic methods used for pattern recognition. These are the steps of my modified Topsis method using proposed fuzzy entropy and distance measure. Hwang and Yoon developed the Topsis method, the technique for order preference by similarity to ideal solution method. This method fundamentally promises in terms of geometric, the option selected should be one of the closest to the ideal solution. What I am talking about, I am using my fuzzy entropy and distance measure in Topsis method to select a sustainable renewable energy source based on the different conflicting criteria. These are the steps. First, we create a decision matrix. There are some alternatives. Then there are some criteria. This is the decision matrix. Then we normalize the decision matrix using the equation 15. Then the important part of this method is to compute the criteria weights of the different criteria, because we cannot assign the equal weights to different criteria. We have the most commonly method is entropy weight method to calculate the weights of the criteria. Then we calculate the ideal solution. Ideal solution means distance. Ideal solution means we select maximum and minimum of the uh, uh, for benefit and cost criteria. Then calculate the distance from positive ideal solution and negative ideal solution. On the basis of these calculate the relative closeness degree, on the basis of which we rank the alternatives. This is the case study. We have taken hydropower, fourth is geothermal power, fifth is biomass power, and sixth is hydrogen power. These are some criteria to evaluate these alternatives. First is cost, second is efficiency, third is environmental impact, fourth is energy density, fifth is government incentives, sixth is scalability, and seventh is public acceptance. This is the fuzzy decision matrix by taking into account the different experts regarding the performance of alternatives based on this criteria. Then we normalize this fuzzy decision matrix using the equation 15. Then we compute relative closeness degree, which are represent the relative closeness degree on the basis of ascending order. Then we rank the alternatives. From this table, we can see that the maximum value is for alternative 4. It means geothermal and geothermal power is the best alternative among these alternatives. This is the conclusion. In this paper, we have introduced fuzzy entropy and this, and these are some references which I have used in this paper. Thank you. Any question?
Right, Mr. Manish?
Anji sir. Yes, sir.
So you said there are a lot of entropies already there, right?
Sir,
uh,
what I have not mentioned in one slide, I have invited a different experts
how your
different
methodology?
field. They shared their opinions of different. My method, my suggested method, calculate relative to different criteria.
No, how your method
Actually,
is better than your suggested method?
Actually, sir, my suggested method is a multi-criteria decision-making method that selects the best alternative related to different criteria.
No,
By considering the
you have
opinions
your
of
own entropy. You have your own entropy, right? There are a lot of entropies already there.
I have
right?
suggested my
You have suggested your
entropy,
right? So where you theoretically proved
yes, sir.
your entropy is better than the other entropies.
Yes, sir. I have actually number of slides are greater than 40, sir. I have not included. I have included in the main paper which I have shared to the institute that my suggested.
Okay, in one or two words, can you tell how?
Criteria for different
Your audio
criteria.
is, okay, a little bit slower because your audio is not in a flow.
My suggested entropy, sir, calculate the different amount of ambiguity for different fuzzy sets. My suggested entropy calculate the different amount of weights for different criteria, and my suggested entropy satisfy the condition of linguistic variable.
Okay, I'm asking how your suggested entropy is better than the existing entropies. Can you able to
sir,
prove
can
it?
can I share?
Have you proved it in your paper, in full paper?
Yes, sir. I have proved this in my complete paper, sir.
Complete paper. Because that I want to know. Because you are telling your
I have taken, sir. I have
Ah.
taken 3 examples to prove the superiority of the suggested fuzzy entropy, and I have taken 2 examples to prove the superiority of suggested distance measure.
No. Suppose if you want to prove something, right? If you want to disprove something, you can give examples. But if you want to prove something, you have to prove it theoretically. Okay, whatever you think, it's good, right? Because your work is good, right? But what I'm suggesting is, whenever if you want to prove something, right?
Yes,
in general,
yes,
you have to prove it theoretically. If you want to disprove something, you can give counter examples. Okay, 1 or 2 examples you can tell, and you can say this is better than this is better than this, right? Only for disprove. But if you want to prove something is better than the other thing, then you have to prove it in a theoretical manner. But still, there are a lot of entropies are there, right? And one is better than the other, and still you have your own entropy, and you are doing it. It's a good one, right? Even though you are not compared with your entropy with other entropy, but still, right? You are also having your own way of entropy, right? And you can apply it in Topsis method, and you can show your results in your in here also. But can you do one simple thing, right? You can take the same problem and try to solve it using the other entropies, and then compare your results, right? And compare your results. Have you compared, Manish? Okay, no problem. Yeah, some.
Sorry, sir. I lost.
Okay, no problem. Because one. Okay, right. Okay, right. But anyway, you have done a good job, right?
Thank you, sir. Thank you.
Right, good job. But only thing is, in the next level, right, you have to show your entropy is superior than the others.
Yes.
But that can be done only not by telling the case studies or one examples. That should be proved through theoretically, right? Your thing is much better than the others under any circumstances. Under any circumstances.
Okay. Thank you. Thank you. Thank you so much, sir.
Good.
Any other questions, sir?
Okay, good, Manish. No,
Thank
no,
you.
no.
Thank you.
Yep. Okay.
Thank you.
Next person.
Next person, Dr. S. Mallika. S. Mallika, ma'am, ready?
Excuse me, ma'am. Sorry to disturb. Am I audible now?
Yes, ma'am. Mallika, ma'am, are you ready? SK Priya,
Yes, ma'am. Yes, ma'am.
are you ready, ma'am?
Yes, ma'am.
Okay. You can share your PPT, ma'am.
Okay. Hello, ma'am. Hello. Ma'am, can you see my PPT?
No, ma'am, it's 14 minutes.
Okay. Okay. So, just like
Now it's visible, ma'am.
okay, I'll start, ma'am. I'll just put a slideshow. Open this one. Can and can I do like this? Is it visible?
And
Make
make
it
it
as a
a
full
full
screen.
screen, ma'am.
Make it as a full screen.
Is it visible, ma'am? Can I
Yes,
start now?
ma'am.
Okay,
Okay,
move on. You can move on. Move on.
okay,
Slide by slide.
myself, Priya, research scholar. My guide is Dr. J. Priya. I'm doing this Satyabama Institute of Science and Technology. My paper is a study of minimal and maximal labeling across various craft classes. Then these are the outline, introduction, existing approaches, problems in existing approaches, proposed methodology, result and discussion, conclusion and future work references. An introduction, actually, graph theory was introduced in 1736 by Leandre Euler in knowing flow graph. Actually, graph theory was the study of graphs for mathematical structures, as all know, and in graph theory, it's a popular area in which contain theories such as Hamilton graphs, eigenvalues of graphs, etc. And focusing on graph labeling. Graph labeling is an assignment of integers to the vertices or edges or both subject to certain condition. It was first introduced in Lex Ross in 1967. Actually, I'm using this definition, the minimal labeling and maximal labeling. A graph, actually minimal labeling means a graph G with vertex set V of G and edge set E of G. Then order of V of G is less than or equal to order of V of G is called minimal graph that denoted as mean L of G. If there exists an edge labeling F from E of G to the set 1, 2, etc. are such that the induced vertex labeling F star of P is equal to minimum of F of E is incident on V. And for any two distinct vertices U and V belongs to the vertex set such that F star of U not equal to star of V. Same way we can define the maximal labeling instead of minimum, we can do maximum. Then these are the existing problems that are these all sections cycle, wheel graph, bi-star graph, star graph is not admitting minimal and maximal graph. All others, middle graph of Sn, total graph of Sn, splitting graph of Sn, bull graph, and the middle graph of bull graph, total graph of bull graph. These all satisfying minimal and maximal labeling is already existing. In my paper, I just take the other graphs like here regular graph, close the helm and flower graph. These graphs I take, just apply the minimal and this definition. I just find out the result like every k regular graph k greater than or equal to 2 are minimal. That satisfy the minimal and maximal graph. Every 3 are not a minimal and maximal graph. Also, Helm graph and closed Helm flower graph activates the minimal and maximal labeling. Then these are the proof of the theorems. Every k regular graph with k greater than or equal to 2 are minimal and maximal graph. If you are taking a k regular graph where we know km by 2 are just having the graph, then we define the function g from of g to 1, 2, 3, etc. km by 2. Then the induced vertex function is defined g star of v is equal to this one. Therefore, k regular graph, each vertex v must have a unique minimum at level among its k incident edges such that no two nodes are sharing the same minimum level. That implies we actually are using the definition of minimal labeling that we get k greater than or equal to 2 that satisfy the maximal graph. Same way, if you are taking any tree, in minimal graph, by the definition itself, order of E of G is greater than or equal to order of E of G. So, but it's not satisfying that condition. So, tree is not a minimal or maximal graph. Same way, we have explained the Helm graph is not is satisfying the minimal labeling. This is the theorem proved. And again, this is the closed Helm graph and flower graph also satisfy the minimal and maximal labeling. In the conclusion, use the definition of minimal and maximal labeling, define the same for different graphs. Then in future work, I just focus on the application of this labeling. Then these are my references. Thank you.
So, Ms. Priya, right?
Yes.
So,
Yes.
you have shown that study on minimal and maximal labeling across various graph classes,
Graph class.
right?
Yes.
What is the why you studied this? Because what is the objective behind studying minimal and maximal labeling of graphs and where it is applied?
Actually, in that root network for efficient communication, we can use this reducing the unique minimal labeling like that. You can apply the, actually, I'm trying to do the next level.
Because here you are shown there are some existing graphs are there, and you are using the definition of minimal and maximum labeling, and you are showing okay, this graph has minimum labeling, this graph has maximum labeling. Right.
Yes, yes, I just
Right.
theoretically.
So where is your core work? Because we are taking a study on minimum and maximum labeling, right?
Yes,
Across various graphs. But
graph
all the graphs
class.
is already there. Whatever the graphs you are telling, it's already there.
Actually,
Right?
that I only introduced this. That's my previous paper.
No. Minimum labeling and
Existing
maximum labeling is there or not?
various classes. Actually,
No. Whether minimum labeling definition, maximum labeling definition is already there. Right?
no, sir. This definition we introduced it is minimal labeling and maximum labeling. This
Minimum
is our
labeling and minimum labeling, maximum not at all exist in the theory itself. The theory of graph theory.
labeling.
Minimal and maximum labeling is there in the literature of graph theory or not?
This definition I was actually.
Because if you tell something new, the definition, then the definition itself should be proved first. Because you only define minimum labeling and maximum labeling means the definition should coincide with all other theorems of graph theory. We can't define something new without it coincide with other things. So that I'm asking whether the concept of minimal and maximum labeling is already there in the graph theory or not.
It's not all this definition is not there in the graph theory, sir.
So you are taking your, so can you show your own definition?
Okay. Sure. Yes, sir.
Okay, this is your definition, right?
Yes, sir.
So if you define something new, right?
Yes, sir.
Then that it should be coincide or it should not violate the other basic concepts of Kafkian. Have you checked that thing or not? So
Oh,
how you define minimum labeling? You just explain the
minimum
definition because this is your definition. You tell me how you are defining minimum labeling.
labeling.
Hmm.
If there exists an edge labeling from U of G to R, then there exists
No,
an
what
inverse.
is F is a function,
Yes,
right?
sir.
F
Yes,
is
sir.
a function moves from E
Function
of
from
G
E of
to
G to
1
set
to
of
R.
integers.
What is
One
E of
to-
G?
Pardon, sir. E of G is the edge set.
Edge set, right?
Yes, sir.
So edge set
Yes.
takes the value from 1 to R. Why it takes only from 1 to R?
Sir, integers I just mentioned.
No, why it is 1 to R? What is R?
Actually, it's a set plus actually integers I just mentioned. Natural number.
Okay, right. So such that the induced vertex labeling
Mm.
F star of V equals to minimum of F of E. E is incident on V. What is the meaning of E? E is a edge.
Edge incident on
V.
vertex.
V.
The
What is the meaning
particular
of
F star of F star of V, that particular V, that edge E is incident on that particular V.
what is that minimum of F of E?
Minimum of F of E means in V, the vertex V, many edges are there. So from that edges, the
No,
minimum we
F
can
of
take.
whether F of E having only one value or number of values.
Suppose F of in a vertex, we have sometimes many edges are going
No,
from
no. So
one
see,
vertex.
I'm asking mathematically. Minimum of
Yeah.
F of E. But F
Yes,
of
sir.
E is a one number. If
A
you
single
say
number.
minimum
Yes,
of
yes, yes,
minimum
yes,
of
sir.
numbers means that should be F of EI.
F
F
of
of
I.
EI. F of EI. Then if it is F of EI, then some
Okay,
particular
okay, okay.
I, then you
Okay,
can it will be a minimum one. Then that will
okay,
be equal to F star of E. Similarly for maximum also, if you put
okay, ma'am.
maximum of F of E means it should be F of EI.
Okay, okay, sir.
That only I
Sir,
was because
yes.
if it is your definition, right? Then if you
Yes, sir.
find a minimum of, then you can take a minimum only from a collection,
Yes,
right?
sir.
But here F
Okay,
of
okay.
E
Yeah.
represents a single thing. So that I'm
Yeah.
asking your
I'll correct.
definition.
I'll correct.
Right? So whenever you define something new or yourself, right, you should be thorough with your definition first, right?
Okay, okay, sir.
Then you can move on. Then you can
Okay,
move on because there you put minimum of F of E and maximum of F of E, right? But
okay,
F
okay.
of E should be a collection, right?
Yes,
And
sir.
that
Yes.
collection you have to define in a proper manner. What is the
Okay.
collection? And in that collection, you can find a minimum that you start. And one more thing also, you can put the F star of E here also F star of E. But if when you label something a minimum maximum, at least you have to show some there F star or here F some because both notation is F star V F star V. Whether it references minimum or maximum.
F star of U.
There also put F star of E represents minimum. Then the next
Yes.
definition also you put F star of E is represents maximum, right? Then
Okay.
for any F star of E represents minimum or maximum.
Okay, that I'll note, sir.
Right. So the
Okay.
idea is good. You are doing something new, right?
Yes, sir.
But whenever you define certain things newly, right? You just first you concentrate on your definition first and define it
Okay,
in a
sir.
very proper manner, and then your definition should not violate the other things also, other
Okay,
concepts of
okay.
that area also, right?
Okay, okay,
Okay.
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 Okay, thank you, sir.
Yeah, it's
Yes, sir.
already go through the website. Minimal labeling and maximal labeling is already exists. Try to go through it and then check whether it's whatever you have shown is the same as already exists. So check it. Without checking, you should.
No, this definition not existing. I already
So that
checked.
I'm asking, Priya, you are telling it's you are only defining,
Yes,
right?
sir.
Even if
Yes,
you want
sir.
to define your minimum labeling, maximum labeling in a different manner, you can do it by your own way, and you can tell, right? The previous definition of minimum labeling and maximum labeling, right? And my definition of minimum labeling and maximum labeling is better than the previous definition. Something you have to do, right?
Okay,
So that
okay,
I'm telling, right?
okay, okay, sir. Okay, thank you, sir.
That's fine. You can
Okay.
next person.
Thank you, ma'am. Thank you. Okay.
Next person, Miss S. Malika. Malika ma'am, are you ready?
Good afternoon, ma'am. Yes, ma'am. Ready.
your PPT, ma'am.
I'm visible now, ma'am. Ma'am, audible?
Yes, ma'am. It's
Okay.
audible.
Audible, not
It's
visible,
not.
ma'am.
Ma'am? Ma'am, PPT is visible? Hello?
No, ma'am. PPT is not visible. Your voice is audible but not visible, ma'am.
Wait. PPT not visible. Ma'am, here, visible, ma'am?
No, ma'am.
Visible in your, visible in your, share screen. Share screen. Ma'am, visible, ma'am? Ma'am?
Yes,
You
ma'am.
start. Yeah.
Yes, ma'am. You can see.
Okay, ma'am. Good afternoon to all. Myself, Mallika. My paper topic is complete graph and self-invertible matrix in encryption and decryption. The outline of the paper is introduction, existing approaches, related works, proposed system, problems in existing approaches, conclusions and future work, references. The introduction is for cryptography is the one of the important mathematics from hackers and increase the security of the transfer data. Cryptography is the process of wait a minute. Cryptography is the process of converting messages or plain text into unreadable and unrecognizable so that the only deliberate recipient can remove the distinguished form and read the original plain text message. The hackers or intermediates do not identify the data. The message we are sending is known as plain text, and the unrecognizable form of the message is called encrypted text or cybertext. Although both plain text and cybertext are written in the form of alphabets. Existing approaches for this paper, cryptography in latterly period is widely applied in graph theory, number theory, network security, secure communication, online banking, and blockchain technology, etc. Next, symmetric cryptography. Symmetric encryption is one key per session. Asymmetric encryption is private. There are two keys, private and public key. So basic definition is
Madam, you can move on to your the definitions no need. Definitions no need. Definitions no need. You can go
so
to your idea.
This is a definition using for key for self-invertible matrix. In this paper, we using key for self-invertible matrix. The basic algorithm for complete graphs based on encryption algorithm. Step 1. The given plain text message is to be converted into its numerical equivalent values. These numerical equivalent values are put into the edges of an undirected graph. Create a path of n vertices depending on the number of requirements beginning with vertex 1. Draw a Hamilton path, assign each weight, and then compute the adjacency matrix of this Hamilton path. Name this matrix. For the key matrix, we are generating a self-invertible key matrix of even order. Since the key matrix is even, the adjacency matrix must be of order even. In case the given path doesn't form an even order adjacency matrix, we have to make that into the form of an even adjacency matrix by adding some dummy edges with false weights to the existing Hamilton path. After generating a self-invertible P matrix, multiplying it with the adjacency matrix, the final resultant matrix is the encrypted data for the original message units. Finally, this encrypted matrix shared with other users over an unsecured channel, either row-wise or column-wise, also represents the number of vertices, that is I, n, where I is the index value of the given Hamilton path, n being a size of the matrix. Next, complete graph based decryption algorithm. With the help of received data, the receiver is able to find the index value, order of the matrix, and the matrix, which helps to generate the self-invertible matrix. The receiver will then separate matrices. The given encrypted matrix can be multiplied with the generated self-invertible P matrix. Trace back the graph with the help of the above resultant matrix and write the edge length of the graph from the given index value. Decode these values with their numerical equivalent values. Then finally, the receiver is able to identify the original message. Problem existing in approaches. Suppose that user A is the sender and user B is the receiver. User A wants to send the message God, and using the above technique, assume that both users know the encryption and decryption techniques of the given procedure. So one example for this one, complete graph and the solving. Compute the adjacency matrix for the above complete graph and it is denoted by P. Now we need to compute P matrix for the purpose. We consider self-invertible P matrix M with the help of n by 2 in M22. So conclusion, a new approach to improve crypto system using graphs and self-invertible matrices has been proposed in this study, which uses the concept of Hamiltonian path, adjacency matrix, and self-invertible matrix in order to increase the security of our information. My future work is this approach will be modified and to be used for some other advanced graph theory concept, self-invertible matrix of any order, also to extend this approach to image encryption and decryption, etc. So these are the references. Thank you.
So the Ms. Malika.
Yes, sir.
So what are the algorithm is shown? So that is the algorithm is written your area of work, or it is already there in the literature?
There are in the literature, sir.
Okay, that algorithm is already in the literature. That so where is your exact work is there?
Sir?
Your exact work, because you told you are that algorithm, that step 1, step 2, step 3.
Yes, sir.
That is already there in the literature. So what is your exact work on this?
Here I am using Hamiltonian path and the complete graph, sir.
Oh, that is already there. Hamiltonian path is there. That algorithm is also there. But I'm asking where is your work? Why you take the Hamiltonian path and you just tell at least one application of this, one application of this where you can use.
Hello, sir.
Because you tell God is a message from A to B, right? Can you tell how we can use this idea or use this algorithm? We can decode the word God, and then we can again back to the letter. How because you have to tell some algorithm is there. then you have to clearly explain how that algorithm works for a particular example.
Particular example, sir.
Because you already told someone example, God is a word.
Yes, sir.
Can you tell how it works? Previously, the previous graph, complete graph, you tell
Yes,
one previously.
This, sir.
No, it is not. Here you tell, assume that both users know the description techniques. So can you explain this, how you use the particular algorithm
Yes,
to
sir.
move this message from one person to another person?
Sir, you have to take encoding table, sir, using encoding table.
That
In
only I'm
numerical
asking.
values
Because
1
here you
to
are telling some,
26, sir.
here you, no, here you are showing one complete graph. How
Okay,
this
sir.
complete graph is connected with your word God.
Sir, we have to take only 3 edges, sir. 3 edges, 4 vertices, sir. God, G-O-D, God. We have to include false edge, sir. False edge. We get incomplete graph, sir.
No. Here you have 4 vertices and how
Yes.
many edges you have?
3 edges are there. 3 edges.
Only 3 edges.
Only 3 edges.
You have to say which are the false edges.
Sir, which E to H, E to H, G to E, H to F are false edges, sir.
Then where you mentioned that is a false edge?
Sir?
How can we know that is a false edge?
Sir, for a G encoding table, we using encoding table, G is having 5, sir, number. Sir, in alphabet letter, 1 to, say A to Z, we have to put 1 to 26, sir. So we have to take God means G. G have 5, represent 5, sir, number 5.
How?
And 15 is O is represent the number 15, sir.
But there's no O here.
And 7 is D.
No, there's no O here.
Sir?
In your graph, your G, F, E, H. Where is
E, F, G, H, sir. G, O, D. Sir, G is 7, O is 15, D is 5, sir. Sorry, sir.
But where is O?
Sir?
O is
FG, FG, sir.
FGH is O.
Oh, yes, sir.
Then what is G?
G means GFE, sir. EF.
Then, because for the layman perspective, how we can understand from this particular thing, EF represents G, then you will tell what are the false edges.
Edges, okay, sir. Definitely, sir.
What are the false edges here?
False edges are E to H, G to E, H to F, sir.
Can you show it in your paper? Because here only one slide is there.
Yes,
from
sir.
there we can able to understand.
Okay,
and
sir.
you go to next slide. Go to next slide. Next slide. Now how you get these numbers?
Sir, adjacency matrix, definition of adjacency matrix.
Right. So how you get 2315 and 2325? From where?
23, 15,
25.
25. So we get the vertices E, F, G, H, sir. Here E, F, G, H. In row wise also E, F, G, H, sir. So first one, E to E,
nothing is there.
E
so you
to
put
E.
Z. So you put 0.
Then E to F is 7, sir. Next, E to G.
That's 23.
23.
25. So right. So in
25,
this matrix, which are the false edges?
Sir, E, H, E, F, G, E, sir. These are the false edges, sir.
Then how you get that thing as false edges? Whether you shown in your paper?
Sir?
No, madam, you suddenly tell this, there are some edges are there that represents the words God and other things are false edges. But how you get this? Okay, you go after this, after the matrix, then what you do? Okay, you get a matrix. Then matrix, then what you are going to do in this matrix?
So now we need to compute the key matrix, sir, using self-invertible matrix, sir.
Where is the key matrix?
So here I will not show here, sir.
That you have to tell them, madam, because you have shown some algorithm. The
Okay,
algorithm
sir.
is already existing,
So,
right? Then if you apply your own problem,
okay, sir.
means then you have to show the
So
algorithm how that here
we're
you
using
are
here this
putting.
formula, sir.
Okay, here also here you are giving the definition, right? Then
Yes,
you
sir.
tell the step 1, step 2, step 3 also, right? Then you go to
Okay,
next
sir.
slide. This is step 1, step 2 based encryption algorithm,
Yes, sir.
right? Then you move on. Okay, your step 4. Then you move on. So
Encryption.
this is for description algorithm. The one is for
Yes.
inscription algorithm, another is for description algorithm.
Yes,
This
sir.
is already there in the literature, right?
Yes, sir. Yes.
Right. Then now, what is your work?
Sir, in self-inverted matrix in last literature, using Euler path, sir. Euler path, I
No,
have
that
been
no,
using.
whatever work you have to clearly mention that one thing. Then whatever work you are doing, and then how this procedures, right, are applied there, because you are putting 1, 2, 3, 4 for inscription and step 1, 2, 3 for description.
Yes, sir.
That should be clearly mentioned in your matrix, but matrix is not there. There's only one matrix, and then you go for the conclusion. But we should know how it is applied, and exactly we know what is your work on this thing. Invertible matrix is also there in the literature itself, right? Invertible matrix is also there in the literature itself.
Yes, sir.
Right? So we should exactly know what is your work on this and how this encoding and decoding is working in a complete graph. You are showing some graph. So
Yes,
forget
sir.
that word God, God, right?
Yes,
You
yes,
show
sir.
some graph, right? And
Yes,
you
sir.
convert that graph into a matrix.
Matrix.
Then you should show that how that algorithm, right, works on this
So
particular
we
matrix.
using algorithm, we have to find.
Right, madam, that you have to show, because
Yes,
you
sir.
you tell that matrix, then you have to tell how the algorithm is on that particular matrix, and you have to tell how you can encode and you can decode.
Okay, sir.
That only we ask,
Okay, sir.
right? Oh.
Think about other than efficiency matrix. Why don't you think about incidence matrix and all those things? You can think about and try to proceed.
Okay.
Instead of efficiency matrix, you can use it. Okay.
Okay. Bye.
Next person.
Next person. Alex ma'am, are you ready? Vijayalakshmi ma'am.
Yes, ma'am, I'm ready.
Okay, ma'am. Share your PPT, ma'am.
Yeah. Ma'am, is my PPT visible? Hello?
Yes, ma'am.
Yeah. So with the permission, I'll start my presentation. Myself, Mrs. Vijayalakshmi, working as a research scholar in MGM University under the guidance of Pawar sir. My title is Finding the Shortest Path in Transportation Problem using the Dijkstra's Shortest Path algorithm. So we have two very uh, known problems. One is in optimization techniques, that is the transportation problem. Hello. And second is the Dijkstra's algorithm, which finds the shortest path in any of the network. So I tried to combine these two and introduce this. And this is how my flow is as per the instructions given by the team.
Okay, so kindly mute others. So I request the other participants kindly mute yourself. Except the presenter, all the other participants kindly mute yourself.
Shall I proceed, sir?
You can proceed, madam. You can go directly to your problem, madam. That introduction, no need,
Okay.
because everybody knows the shortest method, right? So you can go,
Oh,
what
okay,
is your
sir.
idea? Or what
Okay,
is your
sir.
proposed
So
method?
yes, sir, fine. So the most popular method to find the transportation problem is northwest corner method, least cost and Google's approximation, and this will give the initial basic feasible solution. And next, to modify that, either we have to go with the modified distribution method or stepping stone method to get the best result for the transportation model. But if I can convert this transportation model into the graphs, then I'll get a complete bipartite graph. So I try to apply the Dijkstra's algorithm to get the shortest path of a transportation with the minimum cost. So these are the methods, existing method. Actually, there's no problem in that. I just thought of applying this. The only thing is IBFS we get, and then we need to modify this, or either we can go with the simplex little complex problem, simplex method, which is little complex according to me. The next is model the transportation network as a graph with supply and demands as a nodes. And when it becomes a graph, we can apply Dijkstra's algorithm from one node to other node, and the edge indicate the cost of transportation. So by calculating the shortest path, we can allocate the goods and get the shortest transportation problem, which is nearer to optimum. So this is what the thing which I am doing, sir. This is what the work I am working on it. And the problem with this is I need to go with a one more word called as a transshipment problem, because theoretically in the transmission problem it is a complete bipartite. So I converted that into a network by using a transshipment problem. That is the next work which I am doing it. When I write this, this was the thing with the work. And results are efficiency. For large-scale transportation network, Dijkstra's algorithm offers a computationally efficient method to find the shortest path. Flexibility is there, and practical application is Dijkstra's algorithm is already widely used in routing and networking flows, making it easier to apply the transportation logistics. So these are what the advantages of applying Dijkstra's, which made me to apply this to a transportation problem, which is in the optimization technique actually. And this is the conclusion. By modeling a transportation problem as a network flow problem, we can compute the minimum cost between supply and demands. And here that comes as a transshipment problem. I need to convert the transportation to transshipment, and I can apply the Dijkstra's to this. So these are my references, and thank you, sir.
Madam Vijayalakshmi, madam. So,
Yes, sir.
so your idea is transforming that the transportation problem into a graphs, then
Graph.
bipartite
Yes.
graph, then you can apply Dixit algorithm, right? So can you
Yes. Yes,
have
sir.
you worked out that thing? Yeah, and whether you
Yes,
are,
sir.
have you worked it out in your paper?
Yes, sir.
So, uh, have you ever tried whether it is already in the literature or not? Whether Dixit
It is not. No, sir. It is not there in the literature. These are the two different things. One is from
no.
optimization and one is from graph theory. So I'm combining these two.
No, because
Uh,
nowadays that optimization, most of the things are there, because the same thing
okay.
can be do it in through there are a lot of graphic representation. Even if you go to GPM path, that also looks like graph
Yes.
networks, right? So networking is
Yes.
already
Yes.
there
Yes. That is project
in
management. Yes.
so networking is already there in the optimization techniques, right? So I
Right,
want
sir.
to know whether your digital algorithm applying this tool, because if you tell this is not at all in the literature, then you have to show how your methodology is better than the existing methodology.
Uh,
Because there
to
are
be
some
very
existing
honest,
methodologies
sir,
are there.
yes.
Because have you shown that your digital algorithm methodology is better than Modi method and other thing?
Yes, sir. Actually,
How?
my work is going on. I have two different answers getting from the modified methods and the extra them. I need to show that it is more efficient than that.
How
I
you can you
just
show?
wanted to
How can
show.
you show?
No, sir. This work is going on. I just
Because
applied a thought. It could be possible. This is
no,
what the paper is.
no,
Even this can be possible, but better
no,
is
madam.
option that I have to check it.
The original thing is right. So if you tell something can be done in a other manner, then you should tell right whether it will work for all. Suppose in the transportation method, there are some unbalanced transportation
Mhm.
problems are there where the demand is not equal
Yes,
to supply.
yes.
Then how your digital algorithm will
Correct.
take care? Then how you
The
can for an unbalanced
unallotted will be the left out, sir.
no, that we can't left out. Because in modi method in other thing we can introduce dummy row or dummy column, and then we can
Yes.
apply the modi method and other things we can solve it. Suppose if
First,
there
we need
can
to balance it and then we can go for the method. Right,
then
sir? Right, sir. I
right
understand. Yes.
but
Yes.
how your digital algorithm will work on that thing?
I'll work on it, sir.
Uh, so whenever you say something is new, then you should understand whether it will work on all forms of methodology, right? So whether suppose you
Oh, okay.
transport, right, the general transportation problem, okay, move from one place to another place, right? So that is
Other place.
right. So
Yes.
that is because basically transportation problem is a particular class of that simplest algorithm, that LPP, right?
Correct.
So,
Correct. Correct. Sir.
suppose if you use it for transportation, then you can use it for assignment problem also, and for any type of problem also you can use it.
Yes.
Huh?
Simplex is used for those also, sir.
But before using that digital algorithm or graph theory idea, you should
Mm-hmm.
understand for suppose the assignment problem or a transportation problem is unbalanced one, then how it will be adapted
Yes.
in the digital algorithm. That one thing. And
Yes.
another
Yes, sir.
thing, you
Yes.
should tell that your digital algorithm is better than the Modi method, better than
Yes, sir.
the
I'm
body method.
working
That
on
is the
it.
second.
Yes.
Okay, these two things you should tell, and you should ensure
Oh,
that Dixit algorithm is not at all used in the transportation problem. You just
yes.
Google it, but suppose if you search in the Google this
Mm-hmm.
algorithm for transportation, and if it is already there, means then you can't say this is a new idea. You just Google it,
Yes.
right, and you
Okay, sir.
try to search
Okay.
Dixit algorithm on transportation problem. If
Transportation
it
problem.
transportation problem, if no results comes for that, then you can say this is your idea is new. But if it is already
Okay,
there,
sir.
because I also seen certain things, because graph theory and then optimization techniques and then fuzzy set theory, all these things have common things in nature, right? So
Okay, sir. Fine. I'll do it. I'll do it, sir.
try to do it, madam. Okay.
Yes. Thank you. Thanks for sir, the suggestion, sir. Thank you.
Next person.
Next person.
Tamil one, you want to ask? Can you ask?
Election ma'am, mute yourself. Ma'am, am I audible? Next person. Deepshika ma'am. Deepshika ma'am. Yes ma'am.
हा 7 स्लाइड्स होते सर आणि कुठलंही डिस्क्रिप्शन नव्हतं फक्त बुलेट पॉईंट्स होते.
Am I audible ma'am? One second. Hello ma'am. Ma'am, you can share your PPT ma'am. Yeah ma'am. Ma'am.
Yes, you can move on. Move on.
Good afternoon, everyone. Myself, A. Deepshika, full-time research scholar at Ayanada Janakyamal College, SKC. I'm going to present my research article entitled on exploring exponential diaphantic triangles over hexagonal numbers. This work was done under the guidance of Dr. J. Kandan. Before going into the main concept, I will discuss about the what are done in this article. Here we define a new type of rectangle called exponential diaphantic rectangles over hexagonal numbers with the sizes nx plus 1, ny plus 2, nz, where n belongs to the positive integers and x, y, z are the non-negative integers, which is satisfying the exponential diaphantic equation, which is hn power x plus hn plus 1 power y equal to z square. And exponential diaphantic equation is a type of diaphantic equation in which the unknowns are in the exponents. In this presentation, I have proved that there is no exponential diaphantic triangles exist over hexagonal numbers. However, there are infinite number of solutions for the exponential diaphantic equation, which has been solved with a special kind of Bell equation. And in this article, I have used this notation ED triangles over HN instead of the exponential diaphantic triangles over hexagonal numbers. These are the basic preliminary definition I have used. One is binomial expansion, and the hexagonal numbers are of the form 2n square minus m. And in Mihalevsky's theorem, in this theorem, for an exponential diaphantic equation, which is of the form a power x minus b power y equal to 1, 3, 2, 2, 3 is the unique solution such that minimum of a, b, x, y must be greater than 1. And another lemma says that for a generalized negative Bell equation, L square minus 8k square equal to 7, their solutions are obtained by the relation which is given us. Next, this is the main definition I have used, that is ED triangle over hexagonal numbers. And this is the first lemma, z square minus 2m square plus m minus 2m square plus 3m plus 1 power l equal to 0. This has no solution for all m belongs to the positive integers and L comma z belongs to the positive integers in b and singleton 0. And the second lemma is 2a square plus 3a plus 2 minus b square has infinitely many solutions, which is obtained by the relation which is given as like that. And the next lemma says that for the diaphantic equation 2a square minus a plus 1 minus b square equal to 0. This is also has infinitely many solution, which is provided as like above. And these two diaphantic equation has no integer solution exist for all any m and n belongs to the positive integers. And this is the main theorem I have proved in this paper. This is the exponential diaphantic equation, that is hn power x and hn plus 1 power y equal to z square. The solutions are only when x equal to 0, y equal to 1, and we get n is like this form, and x equal to 1, y equal to 0. We get n which is of the form where PR must be satisfy the Bell equation and with 3 mod 4. For x, y greater than equal to 2, we have infinitely many solution, and we have proved in the Python programming also. This is the programming for the x and y greater than equal to 2. I have provided the output for the specific limit, just 100. Then by the theorem 1, we proved that there are infinitely many solutions for the exponential diaphantic equation, but there is no triangle, ED triangle exists over hexagonal numbers. By the triangle sum property, there is no triangle exists over the hexagonal numbers. Finally, Finally, this may be used in the cryptographical algorithm in the future. And we may use some other special numbers like triangular number, center square numbers, etc. These are my references. Thank you.
Okay, Deepshika,
Sir.
sir, you can go to your second slide. Second slide.
This one, sir.
Okay, so this you put binomial expansion, right?
Yes, sir.
Okay, so x belongs to z and n belongs to n. So
yes.
z is set of all integers, right? So n
yes.
represents the natural
Natural
numbers, right? And then you define the hexagonal numbers in hn. Your definition
yes.
hn is 2n square minus n, where n should be a natural number, right? Okay, next you can move on to the next slide. Next, okay. So here you also define, right? A, B, X, Y, all these things are there, right? So you go to your next slide. So what is your work on this? Which is your work on this? Because this is already there. Definition is already there, right? You go to your work.
Sir, already we have worked on these triangular numbers. I have worked in the paper is like hexagonal
No,
numbers.
this definition is already there.
Yes,
hexagonal
sir.
numbers is already there. You go to next one. Next one. Okay, you say this is your work.
Yes, sir.
Lemma.
These lemmas are needed for solving these exponential equations, sir.
Okay, so you go to that lemma. You go to that lemma.
Yes, sir.
Right. So here, what is the difference between the set of natural number and z plus?
Natural numbers are starts from 1 to x. Same, sir. Both are same.
Then only I'm asking why. Then you go to next. Then you go to next slide. There also you put lemma 7. Also you put for all a in n and b in z plus.
Yes, sir. Both are same.
Both are same. No.
I will correct it, sir.
Then you put in lemma 8 z plus minus 1. So what is the meaning of that?
That is b greater than 1.
B should be greater than 1. Okay, right. Okay. So the n and z plus same, right? So now you go to the main theorem. So whether this theorem is your own theorem?
Yes, sir.
This is not existed in the current literature.
No, sir.
This is your own theorem,
Yes,
right?
sir. Okay.
So can you able to you go to next slide? Here you put some coding, but where is the proof of the theorem?
Sir, I'm not providing the proof in the presentation.
But have you proved in your paper?
I will put in my full paper and submit.
Because there also you put n belongs to n and x, y, z are all non-negative positive integers. There is no non-negative positive integer. There should be non-negative integers or non-positive. Non-negative positive integers has no meaning. Right. So that whenever you define something new, right, you just clear about your definitions and then you have variables whatever you are taking, right? That one thing. And if it is your own work, then it's okay, right? And you shown some so if you prove this thing, right? So can you tell where we can apply this? Because this theoretically you proved certain things, right? So is there any application part of this there?
We are working on it, sir, in cryptographical algorithm. But not
because what is the main motive of or main objective on working on this diapartite equation? So where it comes? Because you are putting some equations 2n square minus n power x plus 2n square plus 3n. That is hn. This is hn plus 1, something like that, right?
Yes,
that one you are written here. hn and hn plus 1 you are written like this, right? So why you are taking this particularly and you prove this? What is the motivation behind this and how it is applied? Because suddenly you are taking only hn and hn plus 1. Why can't I take hn and hn plus 2 and prove some other thing?
Already, we have defined two consecutive special numbers, Sn and Sn plus 1. So I have defined Hn as Hn plus 1. Sir.
Okay, because if you really prove this thing, it's good, right? But before proving certain things, you define what is your XYZ in a clear-cut manner, because there you put non-negative, positive. Which one is correct? Whether it is non-negative integers or non-positive integers?
They are negative, sir.
Non-negative integers,
Non-negative.
right? So non-negative integers means should be positive integers. So in that case, you can tell n, x, y, z all belongs to the natural number n itself in a single line, right?
Okay, sir.
If it is so, right? And okay, you proved this thing, okay. But one thing is that whenever you yourself introduce certain new concepts or theorems, right? It should not violate the other proved theorems, right? Because already some proved theorems are there, right? So it should not violate the other proved theorems. That also you have to see, right? If you prove something, right, in general, that general proof should not violate the existing proofs, right? That you have to check one thing, right? If you're able to prove one thing, okay. If you prove something, then you have to check whether your proof is not violating the existing proofs. That's what you should one thing. And further, you should clearly know how you can apply this particular new concept in real life areas, right? Okay. Tamil ma'am, if you want to ask, you can answer.
Nice, ma. Nice work. Try to avoid the symbol notation. Okay. Next person.
Next person, D. Rekha ma'am. Rekha ma'am, kindly share your PPT.
Yes, ma'am. Ma'am, can you share my PPT, ma'am?
Yes, ma'am.
Okay, ma'am. Ma'am, shall I start? Ma'am?
Yes, you can move on. You can move on.
Yes. Good evening, one and all. I am Rekha, research scholar under the guidance of Dr. Adil, Assistant Professor, PG and Research Department of Mathematics, Tirukolanjiyapur Government Arts College. My research field is graph theory, particularly labeling graphs. In this presentation, we discuss about the vertex prime graphs. My title of the paper is Vertex Prime Labeling of Multi-Cycle Graphs. The outline of the paper: introduction, related work, main result, conclusion, and future work, reference. The introduction of the paper: here we consider only a graph which are finite, simple, and undirected graphs. A graph G, the set of V of G and E of G. Here V of G denotes the vertex set and E of G denotes the edge set.
Rekha, you can turn your phone because it is in portrait form. You can turn your phone. You can turn your, because you are audible, but you are putting in your cell phone. Because you are presenting in your cell phone, right?
Yes, sir.
Okay, you turn your cell phone.
Okay, sir. Okay, sir.
Okay, because now.
Okay, sir.
Put it right in landscape. No, because it's not visible. Sir. Because it is, you are in portrait. You turn the cell phone, then it comes into full screen.
Okay, sir.
Now you can use.
Here we consider only the graphs which are finite, simple, and undirected graphs. A graph G is set of V of G and E of G. Here V of G is a vertex set and E of G is a edge set. The order and size of a graph G are denoted by P and Q respectively. Graph labeling, where the vertices and edges are assigned the real values with some condition. Two integers are said to be relatively prime, means the greatest common divisor is 1. The next one related work. The first definition is vertex prime graph, and second one is path. A path Pn has n vertices and n minus 1 edges. And third definition, Cn has n vertices and n edges. My main result, theorem 2.1, the statement of the theorem, two copies of cycle graphs intersecting at a common vertex is a vertex prime graph. The proof of the theorem, let G be a given graph. The graph obtained from the two copies of cycles intersecting at a common vertex. The graph is denoted by 2 of Cn. Let V of G is a vertex set. The vertices are assigned in randomly V1, V2, and so on, V2n minus 1. Here, the total number of vertices P is 2n minus 1. I define the labeling is f of V 1, 2, and so on, 2n minus 1 by f of Vi equal to I for I varies from 1 to 2n minus 1. The next theorem 2.2, the statement of the theorem, three copies of cycle graphs intersecting at a common vertex is a vertex prime graph. The proof is also same like as the above theorem. So the next theorem 2.3, m copies of cycle graphs intersecting at a common vertex is a vertex prime graph, is a generalized theorem. Here the proof of the theorem, let G be a graph, and then graph obtained from a m copies of cycles intersecting at a common vertex, and this graph is denoted by m of Cn. And the vertices, I choose the vertices are V1, V2, and so on, V of m of n minus 1 plus 1. Next, let me see one example of 5 copies of cycle graph intersecting at a common vertex. Here, I assigned the intersecting at a common vertex label is 1, and another labels are assigned randomly. Here, all adjacent vertices are relatively prime, which means the GCD is 1. Therefore, 5 copies of cycle graph is a vertex prime graph. And another, the last theorem, m copies of cycle graphs intersecting at a common vertex at P1 graph is a vertex prime graph. And this is another example of the theorem. This example is also like the above diagram. I attached a single path in common vertex. Here also every adjacent vertices are relatively prime. Therefore, 5 copies of cycle graphs at P1 is vertex prime graph. My conclusion, in this paper, we have considered the multi-cycle graphs and proved the graphs are vertex prime graphs. In my future, we are trying to prove the same multi-cycle graphs are to be an edge prime graphs. There are my reference. Thank you.
Okay. So, okay, Raka, right? So, what are the theorems you have shown? This is your own theorem. It's not at all existing in the literature.
No, sir. This is new one, sir.
So, can you go to your theorem, first theorem?
All theorems are, yes, sir. All theorems are new ones, sir. This is my first theorem.
Okay. So, here you are telling what you are telling. 2 copies of cycle graph intersecting at a common vertex is a vertex graph, right?
Yes, sir. Yes,
so for this, what is your you are showing some example. You are
sir,
showing
this is one of the example of, this is the 5 copies of multi-cycle graphs, sir.
5 copies of multi-cycle graph.
Multi-cycle graph. Yes,
right.
sir.
So if you prove something, right, newly, right,
yes,
in
sir.
general,
Yes, sir.
it should not violate the other concepts in graph theory. I will check that thing. You go to your theorem first. Yeah, what is your assumptions? You have how many vertices?
There are 2 n minus 1 vertices are there.
All right. How many edges are there?
Edges is Edges is not there, sir.
You need only vertices.
Yes, sir.
Edges may be any number of things.
No, sir. We are labeled only vertices, sir.
We're labeling only vertices, but when okay, right.
Yes, sir.
We're labeling only vertices. So how you are
Yes, sir.
labeled? 1 to 2n minus 1.
Yes, sir.
And then according to this pattern, you are telling f of I varies from 1 to 2n minus 1, right?
Yes,
right?
sir.
Okay,
Yes,
then
sir.
you simply put f of v1 and f of v2 equals to 1. What is the
Yes,
meaning
sir.
of that?
The relatively prime, the adjacent vertices are relative prime is 1.
V1 is a vertex, V2 is another vertex, right? What is f of v1? What does f of v1 represent?
F of V1 is 1 and f of V2 is 2. The two vertices are adjacent. The relative, the GCD of the two vertices is 1.
Common divisor is 1. Okay, then
Yes,
what
sir.
is vi comma vn next?
Vi comma Vn is, if we give Vi, I varies from 1 to 2n minus 1, sir.
Okay. Then how you tell that the common GCD between vi and vn is 1?
Sir, excuse me, sir. See this diagram, sir. If we consider only two
No.
cycles,
See, if you
sir.
prove something, no, if you prove something in general, you have to prove
Yes,
it
sir.
theoretically. If you show some example, if you want to disprove something, you have to show some counter example. This is the basic mathematics idea, right? If you want to prove something, you have to prove it
Yes.
in general. If you
Yes,
want to
sir.
disprove something, எதுக்காக ஒன்று disprove பண்ணணும்னா you can give a counter example and you can show that example. See, in this example is like this, so it is not true. But if you want to show something is true, then you have to prove it theoretically. So that I'm asking f of vi comma vn is GCD is 1 means how theoretically it is true. Not because here graph examples you can give, right? Examples you
Yes,
can
sir.
take by yourself and you can give. But in
Yes, sir.
general, f of vi is some number, f of vn is some other number, right? And if you tell the GCD of both the numbers is 1 means it's not acceptable, no. First thing, okay, v1 v2 you tell 1 comma 2 means you are telling 1 comma 2 the GCD is only 1, right? But how can you tell the next line f of vi comma vn is also GCD is 1?
The proof is wrong. F of vi equal to I, you should not take it. You can take it as a prime number. Prime labeling only you are saying. You have to check. You have to take the values as a prime number and then only you can work.
No, ma'am. I take all real numbers, ma'am. Not prime number only, ma'am.
Prime labeling means what? How you are labeling?
The common divisor, greatest common divisor is 1, ma'am.
Yes,
We
that's what I'm
assigned
saying. F of v is the mapping from 1 to 2n minus 1 you are saying, and you are defining that f of vi equal to I means how it is, it is relatively prime, how it is prime. Difference between GCD of, that's what sir asking.
Ma'am, here n is the number of topics, ma'am.
Defining is wrong.
The number of vertices, ma'am. N is number of vertices, ma'am.
N is the number of vertices, exactly. How you are defining the mapping is wrong. F of vi equal to I is wrong. That's what sir said.
Okay, ma'am.
Yeah,
One
try to
more
go
thing,
through it.
right? Because
The example is right. But when we are showing the proof, the step, this part is wrong. F of vi equal to I is the wrong.
see, again, I'm
Okay,
telling,
ma'am. I will check it, ma'am.
if you want to prove something, you have to prove it in general. If you want to disprove something, you have to give a counter example, and you could tell in this example it is like this. So the particular definition or statement is wrong. But if you want to prove some statement is true, you have to prove it in general, right? And there also you put vn plus 1, then suddenly you put v of 2n minus 1. But there are some numbers in between vn plus 1 to 2n minus 1, right or not?
Yes, sir.
So you put v1 comma v2 comma v3 dot 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 Vn, then Vn plus
Vn
1,
plus 1,
1, and then
and so on.
it should be
V
so on, and then 2n minus 1.
2n minus 1.
Okay. But 2n minus 1 is always greater than n plus 1. Suppose you take n equals to 4, 2, then what will happen? N equals to 2.
Sorry.
If you take n equals to 2, then n plus 1 is 3. Then what is V 2n minus 1?
Which is 2n minus 1, which is always greater than n plus 1.
So that I'm asking, when you put n equals to 2, what is n plus 1? 2 plus 1 is 3. What is 2n minus 1? 2 2s are 4, 4 minus 1, 3.
4
Both
minus
are
1,
same.
3.
In that case, right? Okay, so that whenever you prove certain things in general, right, you right from the definition, you have to check, right, how whether it is everything is properly coming or not, right? Then only you can try to prove. But if you want to disprove something, you can give some examples. Your example is correct, that's no problem. But in general, it is not coming, right? So you work on this, right, and try to prove on all these things, right? Okay. Your idea is because you are trying to do something new, right? Correct. But whenever you try to do something new theoretically, right? So you have to look at every direction, and even a single line, single word, or single letter should not violate the mathematical concept. So that I'm asking Vn plus 1 comma Vn 2n minus 1, but both are same when n equals to 2, right? Because n plus 1 is 2 plus 1 3. Here 2 2s are 4, 4 minus 1 3, right? Okay. Okay.
Okay, fine.
Okay, ma'am. Next, ma'am.
Now the next presenter is Harigovindan sir. Harigovindan sir,
Yes, ma'am.
kindly share your PPT, sir.
Okay, ma'am. Is my PPT visible, ma'am?
Yes, sir. You move on. Move on, sir. Harigovindan sir, you can move on.
Okay, sir. Good evening to all. I am Harigovindan, research scholar, under the guidance of Dr. A. Edil, Assistant Professor, PG and Research Department of Mathematics, through Kolanjapur Government Arts College, Virthachalam. I am doing my research work in graph labeling in the field graph theory, and particularly prime labeling. In this paper, we are taking the house graph and proving that the graph are vectors prime graph. So finally, my title is Vectors Prime Labeling of House Graph. Next one, outline, is common to all. Introduction, exciting approaches, problem exciting approaches.
Sir, you can go directly to your problem. No, because all that, because graph theory definition is already there.
Next introduction.
You can go, sir. No need to introduction. You can go directly to your problem. Because already I've seen so many things in graph theory.
Okay, sir. We are using 4 definition. Next. 4 definition, first definition vectors prime graph, second definition path, next definition cycle, last definition house graph. House graph is a simple graph with 5 vertices and 6 edges, where the vertices represent the corners of the house and the edge represent the connection between them. Also, it consists of the square base with the 4 vertices and 1 additional vertex on top connected to 2 opposite corners of the square, show that they are roof. It is denoted by HS. Next theorem. The first theorem, the house graph HS is the vertex prime graph. Proof, let G be a house graph HS with 5 vertices. Let V of G equal to V1, V2, V3, V4, V5. The total number of vertices P is 5. Depend the labeling the function f from V of G into 1, 2, 3, 4, 5 by f of Vi equal to I. I value values from 1 to 5. This is a single house graph. In this graph, every adjacent vertices are relatively prime. The second theorem, the double house graph 2 of HS is a vertex prime graph. Proof that G be a double house graph 2 of HS, that V of G equal to 1, V1, V2, V3 dot dot V2n minus 2. The total number of vertices P is 2 into n minus 1. The dependent labeling the function f from V of G into 1, 2, 3, 4, so on 2 into n minus 1 by f of Vi equal to I values from 1 to 2n minus 2. The next theorem, the dribble house graph 3 of HS is a vector prime graph. This is also similar to last theorem. The proof, let G be a dribble house graph 3 of HS, let V of G equal to V1, V2, V3, so on, V of 3n minus 4. The total number of vertices P is 3n minus 4. Depend the labeling the function f from V of G into 1, 2, 3, 4, so on, 3n minus 4 by f of Vi equal to I for I value varies from 1 to 3n minus 4. The next theorem, the general case, the m number of adjacent house graph MHS is a vertex prime graph. Proof, let G be a m number of adjacent house graph m of HS. Let V of G equal to V1, V2, V3, so on, Vn plus 1, so on, V2n, V2n plus 1, so on, V3n plus 1, so on. The last term, V m into n minus 2 plus 2. The total number of vertices P is m into n minus 2 plus 2. Definitely labeling the function from V of G into 1, 2, 3, 4, so on, m into n minus 2 plus 2 by f of Vi equal to I. The I values from 1 to m into n minus 2 plus 2. In the general cases plus 2 cases, the case 1 m is natural. Short with 1 to short the labeling 1, the second house graph, the V3. The case 2 m equal to 1 modulo n, the short with 1 first house graph. The next theorem, the house graph HS is the vertex prime graph and the lower cycle vertices are increased. This is a diagram. In this diagram, the lower case cycle vertices are increased. The next theorem, the house graph HS is a vertex prime graph and the upper cycle vertices are increased. But in n is odd. Next conclusion and future work. In this paper, we have considered the house graph and proved the graphs we are vertex prime graphs. In the future, we are trying to prove the same house graph or to be H prime graphs. These are my reference. Thank you.
Sir, Argovindan sir, so the theorems you are telling is already existing in the literature or you are proving?
Sir, only single house graph is also acid, but double and three so on general case is not aciding, so it is new one.
So can you show your previous theorem 2.1 and 2.2?
Okay, sir.
Theorem 2.1 நீங்க சொன்னீங்க 5 எட்ஜ் 6 வெர்டிக்ஸ் 6 எட்ஜ் இருக்கணுமா?
Yes, sir.
So that is your theorem 2.1, right? And you are telling is a vertex prime graph. F of Vi equals to I ன்னு அர்த்தம். F of V1 1 define பண்ணுவோம். F of V2 do define பண்ணுவோம். சரிங்களா? அது மாதிரி F of V5 5 define பண்ணுவோம். இதுல எங்க இருந்து நீங்க இத பிரைம் கிராஃப் ப்ரூவ் பண்றீங்க? எப்படி?
So it is a single house graph.
இல்ல நீங்க கொடுத்தது டெஃபினேஷன் மட்டும் தான் சார். F of Vi equals to I ன்னு டெஃபினேஷன் கொடுத்திருக்கீங்க. F டிஃபைன் பண்ணிருக்கீங்க. எங்க ப்ரூவ் பண்ணிருக்கீங்க இந்த பிரைம் கிராஃப்?
So it is a statement, sir.
அதே மாதிரி டபுள் கிராஃப் இருக்கு பாத்தீங்களா? டபுள் கிராஃப் வரும்போது நீங்க என்ன பண்ணீங்க? வெர்டிக்ஸ் முதல் சிங்கிள் கிராஃப் சொல்லும்போது அந்த கிராஃபுக்கு 5 வெர்டெக்ஸ் தான் இருக்கணும்னு சொல்லிட்டீங்க. சரிங்களா? வெர்டிசஸ். அப்ப டபுள் கிராஃப் ஆகற 10 தான் இருக்கணும்.
எஸ் சார்.
இங்க ஆனா 2n - 1 2n - 2 னு ஜெனரலா போட்டுருக்கீங்க. நீங்க அப்படி பாத்தீங்கன்னா ஒரு கிராஃப் நீங்க டபுள் கிராஃப்ன்றீங்க. டபுள் கிராஃப்னால 2n - 2 அப்படின்னா சிங்கிள் கிராஃபுக்கு 5 வரணும் கிடையாது.
சரிங்க சார்.
சரிங்களா? அது மாதிரி 3 கிராஃப் 4 கிராஃப்லாம் போட்டிருக்கீங்க. ஆனா ஃபர்ஸ்ட் கிராஃப் நீங்க டெஃபினேஷன் சொல்லும்போது என்ன சொன்னீங்கன்னா 5 தான் இருக்கணும், 5 வெர்டிசஸ் 6 எட்ஜ் இருக்கிறது தான் ஒரு ஹவுஸ்ன்னு சொன்னீங்க, ஹெச்எஸ்ன்னு அது டிஃபைன் பண்ணணும்னு சொன்னீங்க. இப்போ அதை டபுள் கிராஃப் ஆச்சுன்னா 5 10 தானே மாறணும்.
இந்த definition is
அது ஒண்ணு. சரிங்களா? இன்னொன்னு நீங்க டெஃபினேஷன் டிஃபைன் லேபிளிங் அப்படி சொல்லி லேபிள டிஃபைன் பண்ணிருக்கீங்க. ஆனா எங்கேயுமே நீங்க வந்து அது பிரைம் கிராஃப்ன்றது ப்ரூவ் பண்ணலையே. அடுத்த தியரம் பண்ணுங்க. 2.45 2.5 போங்க.
எஸ் சார்.
2.5 போங்க. இங்க this is a definition. House graph is a vertex prime graph and the lower cycle vertices are increased into ஒரு statement. But how can you call it as a theorem? This is a statement. I am கீழ இருக்கிற vertices நான் அதிகமாக்கியிருக்கேன் அப்படின்றீங்க. கீழ ஒரு சர்க்கிள் பதிலு இப்போ ரெக்டாங்கிள் மாதிரி மாத்திட்டேன்னு சொல்றீங்க. Then how can you call it as a theorem? Right? Whenever you see there are two things are there. Right? One thing வந்து என்னன்னா ஏற்கனவே எக்ஸிஸ்டிங் தியரம்ஸ் இதெல்லாம் இருந்ததுன்னா அதுல இருந்து அப்ளிகேஷன் பார்ட்ல நம்ம ஒர்க் பண்ணலாம். அது ரொம்ப ஈஸி. ஏற்கனவே தியரட்டிக்கலா சிலது ப்ரூவ் பண்ணியிருந்தாங்கன்னா அது அப்ளிகேஷன் பார்ட்ல கிராஃப் தியரியோட அப்ளிகேஷன்ஸ் நிறைய இருக்குது. அது ஏதாவது ஒரு இடத்துல நம்ம எதை பண்ணலாம், இது பாருங்க இது மாதிரி கிராஃப் தியரியில இருக்கு, ஒரு நெட்வொர்க்கிங் இருக்கு, அந்த நெட்வொர்க்கிங்கை நான் வந்து ஒரு ரோட்ல இருக்க சிக்னலுக்கு 4 வழி பாதைக்கு நான் அப்படியே அதை மேப் பண்றேன். மேப் பண்ணி எப்படி ஒரு அந்த கிராஃப் தியரியை யூஸ் பண்ணி எப்படி நான் சிக்னல்ஸை ப்ராப்பரா ஹேண்டில் பண்ணலாம்னு சொல்றேன்னா தட்ஸ் ஒன் வே, ரைட்? But whenever you move on to the theoretical part of concept part of the things போகும்போது நீங்க அதை ப்ராப்பரா ப்ரூவ் பண்ணாதான் அது தான் ஆகும். கரெக்டா? சரிங்களா? சரி சரி. மேடம் தமிழ்ச்செல்வி மேடம்
டபுள் ஹவுஸ் கிராஃப் மாதிரி இட்ஸ் பெட்டர் யூ ஜஸ்ட் நேம் இட் அஸ் இப்ப லாஸ்டா கொடுத்த மாதிரி அந்த சைக்கிளை எக்ஸ்டெண்ட் பண்ணிக்கிங்க அப்படின்னா தான் இங்க எனக்கு இது வரும். ஃபர்ஸ்ட் தியரம்ல இஃப் யூ ஆர் 5 then as said it has to be 9 or 10.
இல்ல சார், எப்பவுமே hs ஒரு கிராஃப் டிஃபைன் பண்றீங்கன்னா you can make it as n vertices அப்படின்னு வச்சு தான் என்ன பண்ணணும். நீங்க அதை 5 ன்னு வச்சு நீங்களே ஃபிக்ஸ் பண்ணிட்டீங்கன்னா அப்புறம் டபுள் கிராஃப் டிஃபைன் பண்றது அர்த்தம் கிடையாது. அது நீங்க n ஃபிக்ஸ் பண்ணி அப்புறம் 2n 3n கொண்டு வருது வேற. ஆனா ஃபர்ஸ்ட் ஒரு ஃபிக்ஸட் நம்பரா ஒன்னு ஃபிக்ஸ் பண்ணிட்டு அப்புறம் அதுல இருந்து எக்ஸ்டெண்ட் பண்ண முடியாது. எப்பவுமே ஒரு வேரியபிள் தான் n வேரியபிள் 2n வேரியபிள் 3n வேரியபிள் என்ன பண்ண முடியும், எக்ஸ்டெண்ட் பண்ண முடியும். 5n ஃபிக்ஸ் பண்ணிட்டு ஒரு நம்பர் ஃபிக்ஸ் பண்ணிட்டு அப்புறமா அதை என்ன பண்ண முடியாது, மேத்தமெட்டிக்கலா எக்ஸ்டெண்ட் பண்ண முடியாது. சரிங்களா? ஓகே ஓகே ஓகே, தேங்க்ஸ்.
Same thing for giving the proof, you have to give the full proof. Otherwise mapping மட்டும் டிஃபைன் பண்ணிட்டு பாதியில ஸ்டாப் பண்ணாதீங்க. Don't stop with the proof.
Sorry ma'am. I will learn.
Yeah. Next person ma'am.
Yes ma'am.
Next person, Tenmoli ma'am.
Yes ma'am.
You can share your PPT ma'am.
Okay ma'am.
Tenmoli ma'am.
You share me
Ma'am, your voice is breaking ma'am.
Not supporting PPT ma'am. You share me.
Okay ma'am, I will show.
Madam, so everything was okay?
PPT is visible, sir?
Yes, ma'am.
Okay, ma'am, you
Yes,
can
ma'am.
start.
Good evening to all. I am SKC research scholar under the guidelines of Dr. V. Garnagaran, Assistant Professor, PG and Research Department of Mathematics, Tirukolanjiyapar Government Arts College, Viruthachalam. I am doing my research work in graph labeling in the field graph theory and particularly prime labeling. In this paper, we are taking the cycle graphs and proving that the graphs are vertices prime graph. My title is Prime Labeling of 2 copies of cycle related graphs. Next, ma'am.
Okay, you can directly
Next
go to your
slide, ma'am.
directly go to your problem. Outline no need, right? Outline that introduction no need, and directly you can go to this is existing approach, right?
2 copies of cycle graph Cn joining a single common vertex for all n is a prime graph. Let G be a graph with 2 copies of cycle graph Cn joining a single common vertex. Let V of G equal to Vi, Vi plus 1. Vi plus 1 such that I varies from 1 less than or equal to n minus 1 union Vn V1 union V1 Vn plus 1 union of Vi plus 1 such that I varies from n plus 1 to n plus 1 less than or equal to 2n minus 2 union of V2n minus 1 V1 and modulus of Vg V of G equal to 2n minus 1. A bijection F is defined by F from V of G to 1, 2, etc. 2n minus 1 such that F of Vi equal to I varies from 1 less than or equal to 2n minus 1. Next slide. Next theorem 2.2, 2 copies of cycle graph Cn joining with 2 common vertices for all n is a prime graph. Proof, let G be a graph with 2 copies of cycle graphs Cn joining with 2 common vertices. Let V of G equal to Vi plus 1 such that 1 less than or equal to I less than or equal to n minus 1 union of V1 Vn union of V1 Vi plus 1 such that n I varies from n less than or equal to 2n minus 3 union of V2n minus 2 V1 and modulus of V of G equal to 2n minus 2. F define. Next theorem, 2 copies of cycle graph
Senmoli, ma'am, your voice is not audible.
Okay. Tell me, ma'am. Okay, it's okay, right?
2
So
copies of
right. Okay, so again it's okay, right? So again, the thing is you are selling is a prime graph. 2.1, 2.2, now 2.3. But where is the proof? Where you proved? Where you proved is a prime graph. Where is the proof?
2.3 ka sir?
2.3 மட்டும் இல்ல 2.12 க்கு எல்லாத்துக்குமே. ஏன்னா you are defining f of ei, f of ej, f of ei define பண்றீங்க, right? But where you proved it is a prime graph.
GC greatest common divisor is 1.
எங்க இருக்குது?
வைக்கல சார். அது ஸ்லைட்ல போடலைங்க சார்.
நம்ம ஸ்லைட்ல போடலனாலும் ஒரு தியரம் கொடுக்குறீங்கல்ல, அந்த தியரத்துக்கு எண்ட் இருக்கணுமே. தியரம் எண்டே இல்லையே. தியரம் அப்படியே நடுவுல நிக்குது.
greatest common divisor f of v1 comma f of vi plus 2 such that 1 less than or equal to I less than or equal to n minus 1 equal to 1.
இல்ல அதுதான் அது ஃபர்ஸ்ட் ப்ரூஃப் பண்ணணும். ப்ரூஃப் இல்ல
Okay,
இங்க.
sir.
இன்னொன்னு நீங்க டிஃபைன் பண்ண மாதிரியும் நீங்க எல்லாத்துலயும் லாஸ்டா எப்படி முடிச்சிருக்கீங்கன்னா f of vi equals to I ன்னு முடிச்சிருக்கீங்க. சரிங்களா? f of vi
sir.
equals to I னா f of v1 1, f of v2 2, f of v3 3, f of v4 4 ன்னு வருதுன்னு வச்சுக்கோங்க. சப்போஸ்
Okay,
f of v2 க்கும் நான் v4 க்கு நான் எடுத்துக்கிறேன்னு வச்சுக்கோங்க. v2, v4 எடுக்கிறேன்னா f of v2 2, f of v4 4, ரெண்டுத்துக்கு நடுவுல காமன் டிவைசர் இருக்குது. அது எப்படி பிரேம் ஆகும்? அது எப்படி பிரேம் ஆகும்?
அது ஆகாதுங்க சார்.
அதனால தான் கேட்கறேன் நான்.
ஓகே.
சரிங்களா? அது முன்னாடி சொன்னவங்க அதே மாதிரி தான். எதை ப்ரூஃப் பண்ணாலும் அந்த ப்ரூஃப் வந்து கிளியரா இருக்கணும்மா. சரிங்களா? ப்ரூஃப் வந்து கிளியரா இருக்கணும். நம்ம எதாவது அப்ளிகேஷன் பார்ட் போனோம்னா அது வேற. அந்த பர்டிகுலர் அப்ளிகேஷனுக்கு மட்டும் அது ஒர்க் ஆகும். இந்த அப்ளிகேஷனுக்கு நம்ம இதை ப்ரூஃப் பண்றோம், இதை யூஸ் பண்றோம் அப்படி சொல்லிட்டு போகலாம். ஆனா தியரிட்டிக்கலா ஒன்னு இன் ஜெனரலா ப்ரூஃப் பண்ணணும்னா the proof should be complete proof. சரிங்களா?
Okay, sir.
Okay.
Okay, ma'am. Next person.
Thank you.
Good evening, ma'am. Lokeshwari, ma'am. Lokeshwari, yes, ma'am. Ma'am, you can start, ma'am. Share your PPT, ma'am. Okay, ma'am. Visible, ma'am. No, ma'am. Your slide is not visible, ma'am. Okay, ma'am. Visible, ma'am? Yes, ma'am, yes. Good evening, all. I am Logeshwari, full-time research scholar. Name of the supervisor, Dr. R. Sriraman, Assistant Professor, Department of Mathematics, SRM Institute of Science and Technology, Katangulathur. Introduction. The concept of gene regulatory networks was first proposed in 1960s. In order to understand the interaction between the mRNA and proteins, gene regulatory network means that the cell governed to gene expression level of mRNA and proteins. Mathematically, it is represented as a graph. Next, generally, gene regulatory network has transcription rate, delay, translation rate, and degradation, and feedback loop is there. My topic is a stochastic gene regulatory network. It is in the mathematical framework used to model the interaction between genes, proteins, and other regulatory elements. These networks account for stochasticity arising from molecular fluctuations due to low copy number of DNA, mRNA, and protein, as well as environmental noise. Stochastic gene regulatory network help to understand how random gene expression changes contribute to cancer progression, drug resistance, and human heterogeneity. It is in the crucial, its major role is understanding predictable, unpredictable biological behavior and improving medical and biotechnological applications. This is my literature reviews.
Madam, you can directly go on to your.
Okay, sir. Title: Stochastic Modeling of Gene Regulatory Networks, Evaluating Mean Square Exposure Stability under Time Varying Delays. Aims: already Shaktivel et al. Investigated asymptotic stability of delayed stochastic gene regulatory network with impulses. Wang et al. Investigated robust stability of stochastic GRN with discrete and distributed delay. My paper is Gene Regulatory Stochastic Gene Regulatory Networks, a mean square exponential stability criterion in the presence of time varying delays using Lyapunov functional EQ formula and Dyking's formula. Some numerical examples are given in from my proposed approach. This is abstract of my research. Problem formulation, the DMA of T, this is the first order derivative of mRNA, and dPi of T is the protein concentration. MA of T, PI of T be the equilibrium point. And then these are under notation of MA of T, PI of T, C and D are some degradation rate, and the constants tau I and hi are delays. U of t and v of t are the which belongs to L infinity. The L infinity, it is in the external input. This is the Hill coefficient, and the activation function is gi of p1 of t minus tau 1 up to pn of t minus tau 1, and then kj greater than 0. Kj values must be greater than 0. It is the Hill coefficient, and xij is a positive constant. Theta ij is a negative or negative constant. My assumption is I have four assumption. First assumption, and second assumption, third assumption, fourth assumption. System 1, already I told the system 1 is mentioned in this equation. External inputs du of t and ui of t and v of t is equal to 0. So this now my system goes to system 2. External input vanishes. That is u congruent t, u of t congruent 0 and v of t congruent 0. Next, this is the general definition of asymptotic stable. My paper work on the mean square exponential input to state variable for phi and psi in Lipschitz condition. U of t and v of t already explained. This is the general definition of exponential stable, input to stable definition. Main results using the assumption 1 and 4, lambda I, Ci, Bi. This is the statement of the theorem exponential stability. I have take the Lyapunov stability function. What is Lyapunov stability function means? The first order derivative must be the negative value. This is exponential condition proved in this theorem. Using this condition, I have take the issues formula for this Lyapunov condition. We get the following results. Finally, this condition is exponential stable over time t. And according to the Dynkin's formula, we can obtain this equation. The initial condition t must be 0 and rho tending to infinity. This is the proof of this theorem. According to the definition 2, we conclude that the system 1 is exponentially input stable. Then the proof is completed. Numerical example using MATLAB, I have given some values in this system 1, stochastic gene regularity networks as follows. This is the diagram. First state system of equation 7 of with system state of the system for first diagram, and second diagram is without external inputs. Next, the state of the system 7 of first diagram and second diagram without noise perturbations in the first diagram. The second diagram, external inputs without the external inputs and noise perturbations. Conclusion of this, my work. Already discussed asymptotically stable and robust stability of exponentially stable in the gene regulatory network. My work is mean square exponential stability under time varying delays using Lyapunov functional, Ito's formula and Dynkin's formula. I have to plan to work. We aim to further extend our study by developing stochastic state estimation for neural networks that incorporate disputed delays, Markovian jumps. This is my references. Thank you. Thank you, sir. Thank you, ma'am.
Okay, madam. It's your work,
Okay, sir.
right? So whatever your assumptions, right? Have you verified your assumptions with the general things? Because whenever you assume certain things, that should not violate the current concepts.
Okay, sir.
Have you tested that thing?
Yes, sir.
Your assumptions won't violate that.
Yes, sir.
Okay. That should
Assumption
be there.
1 with Hill coefficient.
Because whenever you assume certain things, that assumptions should not violate the other existing concepts. Have you checked that thing?
Yes, sir.
Okay, if it is there, then it's a nice one. Okay, madam.
Okay, sir.
So whenever you move further, right? And
Okay,
whenever you
sir.
assume certain things, just try to
Okay, sir.
understand whether your assumptions don't violate the current
Other.
concepts.
Okay, sir.
Otherwise, the results won't be a correct one, right?
Okay.
Okay,
Yes, sir.
okay, okay.
Thank you, sir.
What is the Dunkin formula?
Dunkin formula.
Yes,
One.
you have mentioned.
This is a Dunkin formula. E of D which lambda Q and M of
According
this
to
is
Dunkin, right?
yes, yes, ma'am.
I'm asking what
Yeah.
is Dunkin.
Ma'am, your voice is some not audible, but clearly audible, not audible, ma'am.
Are you able to hear me now?
Yes, ma'am.
What is the Dunkin formula? Formula you
Ah.
are giving some, right? Dunkin formula.
Ma'am,
You are
this is a
not audible
Dunkin
me?
formula. Yes, ma'am, yes, ma'am. Your voice is a break.
This is the Dunkin formula.
1 minute, ma'am. This is Daikin formula, ma'am. This is not generally Daikin formula means T, some X of T variables. In this gene regulatory networks, some time T and mRNA and protein concentrations are used in this theorem.
Okay. Okay.
Okay, ma'am. Thank you, ma'am.
Next person.
Shalini, ma'am.
Yes, ma'am.
Okay, ma'am.
Next presenter is R. Nitya. Yeah, ma'am, are you ready?
Yes, ma'am.
Kindly share your PPT, ma'am.
Yes, ma'am. Yes, ma'am.
Nitya, ma'am, kindly share your PPT.
Yes, ma'am. Sharing, ma'am. Is it visible, ma'am?
No, ma'am.
Ma'am, is it visible, ma'am? I have shared my PPT, ma'am.
Yes, ma'am. Yes. Ma'am, it's visible, ma'am.
Yes, ma'am. Good evening to all. Good evening to all. This is Nitya, Assistant Professor from Rajalakshmi Institute of Technology. My topic is implementation of labeling on rough graphs based on similarity class. So, introduction. This is my outline. So my abstract is we are implementing a labeling zeta labeling on rough graphs, which is called a similarity zeta of VIVJ is equal to zeta by zeta plus eta, where eta is nothing but similarity class of VI and to VJ and similar divided by similarity class of VI with adding with similarity class of VJ, where zeta is defined as vertex labeling of VI and VJ, two vertices labeling plus a number of total number of edges. So based on that, some existing works are some existing works are there based on rough graphs, where Bibin Matthew introduced a vertex rough graph, and based on Bibin Matthew and Based on Vivin Matthew's work, we continued our work by implementing labeling. So next, rough graph definition. Here we introduced we introduced the definition of rough graph based on membership function. Already, rough graph was defined as based on approximation by Mr. Palaka. Here we defined rough graph based on membership function. So the rough graph is defined by where maximum of membership value of AVG is greater than 0 when there edge exists. If it does not exist, then maximum of membership value of AVG is equal to 0. Zeta labeling on rough graph. Here, after constructing rough graph, we are labeling for vertex as a similarity class of VAG with respect to a number of vertices, and edge labeling is defined as zeta by zeta plus eta. So from this, we are taking a data set, uncertainty set. Here, from this data set, we are taking a target set X, where target set is a C2, C8, and C9. That is, it gives the ratio 5, maximum value 5 and 4. So for this, we are defining rough membership values. Rough membership is defined as the ratio between the ratio of intersection of equivalence class and target set to the equivalence class of the set. So we are finding the membership value. We are constructing rough graph. For this rough graph, we are implementing labeling based on similarity class. Similarity class is nothing but by similarity class. With respect to similarity measure is introduced. The similarity measure is defined by satisfying the following properties. Similarity of VI-VJ is lies between 0 and 1, and similarity of any two vertices VI-VJ is equal to similarity of vertices VJ and VI. In such a way, similarity of VI-VK is less than or equal to similarity of VI-VJ, and VI-VK is less than or equal to VI-VJ. Here, similarity class of VI is defined as a similarity of VI, the set of order pairs of VI and VJ is similar. So by this calculation of similarity class, that is, we are finding the relationship between the objects with respect to its attributes. So this is the similarity class of each vertices C1, C2, C3, C4 to C9. Now we are finding the cardinality of vertices for each vertex, similarity class of each vertices. So based on this, we are writing the formula vertex labeling and edge labeling. So vertex labeling is defined as the ratio of similarity class of VI to the number of vertices. Edge labeling is defined. So by finding the values for the vertex and edge labelings, we are implementing the labeling or zeta labeling on this rough graph. This is our labeling was introduced in graph theory, but we are introducing labeling in rough graph theory. So our conclusion here, we are applying new type of labeling based on similarity class and similarity measure on rough graphs, which was constructed using membership function. These are my references. Thank you.
So right, Nitya, am I audible?
Yes, sir.
Right. So you are telling you are done solid graph theory.
Yes, sir.
But you are done in which part? Rough graphs.
Rough graphs, sir.
Right. So how it is useful for rough graphs? Discuss for rough graphs. That is also a part of graph theory, no?
Sir?
How it will be useful rough graphs when studying same concepts in rough graphs, right?
Yes, sir.
So what's your working on
No, sir, can you hear me, sir? Sir, once again, sir.
one side?
Oh, I'm not, it is not audible for me, sir. Yes, sir, one more time you ask me, sir. That is how rough graph was constructed, you're asking, sir.
Because you are telling for how it is differ or how it is useful. Is there any application is there?
Yes, sir. Actually, rough graph is constructed by using rough set theory. Rough set theory is a developed version of fuzzy set theory. So uncertainty problems, we are using rough set theory. For this data, is uncertain data is there. So here, sir, these are all uncertain data. That is similar. Some objects are very similar. All the attributes are similar for some objects, but the decision attribute is different. We'll get the two types of decision attributes. For example, if we take COVID disease, for some patients, all the symptoms are same. The temperature and headache, diabetes and all. But even though the result will be some patient, and the few patients having the result S, or for few patients the result is no. So in such a case, there is an uncertainty in that concept. For that purpose only rough set theory was developed, sir. Yeah, for rough set theory, here only based on data only, still now all the works were going on. So we want to show that data in the form of structure, graph structure. So we constructed rough graph. That's all, sir. This rough graph was constructed. So to construct this rough graph, we have taken the membership function. Rough membership function formula is defined already by Pavak, Zitsula Pavak in 1982. So from the membership values, we are constructed rough graph. So for this rough graph, we implemented labeling as how in graph theory they are implementing labeling for private security, etc. Isn't it, sir? In that such a way we have tried labeling in this rough graph.
Okay, right.
Thank you, sir.
Okay.
Thank you, ma'am.
Yeah, good. Next question.
Next presenter, Dr. V.R. Batmavati, ma'am.
Yes, ma'am.
Batmavati, ma'am, are you ready?
Yes, ma'am.
Kindly share your PPT, ma'am.
Ma'am, is my screen is visible?
Yes, ma'am, you can start.
Shall I start, ma'am?
Yes, ma'am, you can start.
Okay, ma'am. Thank you. Good evening to all. I'm Dr. V.R. Batmavati, Assistant Professor, Department of Mathematics in Jerusalem College of Engineering. The topic of my paper is a novel approach to assessing Hamlet's commentaries using intuitionistic fuzzy set. So first, the introduction is, fuzzy set was discovered by Lotfi Zadok in the year of 1965. An extension of fuzzy set is called intuitionistic fuzzy. It is introduced by Atanasov in 1983. The idea of intuitionistic fuzzy handles uncertainty and vagueness, because a fuzzy set having membership value only, but an intuitionistic fuzzy set having membership, non-membership, especially hesitation value plays vital role in many fields. Here we concentrate deeply upon intuitionistic fuzzy with cosine similarity measure and try to solve a real-life problem, and finally to analyze the Hamlet's infrastructure and key utilities. So existing approaches. First, Smith and Kirkpatrick were introduced to the similarity measures. The study of similarity measure of intuitionistic fuzzy gives specific properties and mode measures in real-life work. The cosine similarity measure is a metric for calculating the similarity of two vectors in a multidimensional space. It's calculated as the cosine of the angle between two vectors. This is widely used in many fields, including information retrieval, natural language processing, and data mining, etc. So another existing measure is weighted cosine similarity measure. So researchers many researchers used this formula. This is weighted cosine similarity in picture fuzzy set. In the special case of picture fuzzy set, membership values are positive, negative, neutral values. So similarity measure is also applied not only in the some other fields. It's also applied in disease diagnosing factors in the field of medicine. So in this case, consider patient similarity measure for their particular set of symptoms and a symptom of selected diseases, for example, dengue, COVID, thyroid, any other diseases that are characteristic for each diagnosis or calculated the higher similarity points of proper diagnosis. Here, my proposed work is modified cosine similarity measure. Here, let us consider two intuitionistic fuzzy set and give some changes in the formula, then finding the solution. So this is the algorithm. So first, to collect the sample data, give the membership and non-membership value of these data by using intuitionistic fuzzy set, and then finally apply the modified cosine similarity measure, then find the values. So the numerical example of this work is, I have collected 10 villages, infrastructure and basic amenities in the following category. So the categories are below categories: Anganwadi, primary schools, middle school, secondary school, diploma institutes, banks, statement, etc. So if these categories, I will give the membership values depends upon the infrastructure and facilities. So these data can be split into two sets of analyzing factors by using intuitionistic fuzzy set. So this is the table 1. First, I will give the membership values. For the analyzing factors depends upon the infrastructure and facilities, we give the membership value. So this is the table 1 and then table 2. Finally, we have concluded the first village, third village and seventh village got the highest range because 0.534, 0.552 and then 0.500. So that's why finally 3 villages have the least infrastructure and basic amenities. So the village surveys provided an insight about the difficulties faced by the villages from a basic facility like hospital, health dispensaries and educational facilities. So these reports were made to bring out the struggles faced by the villages to the public sphere and take relevant measures. So in this paper, the proposed method was helped to increase the accuracy level. And then these are my references. Thank you.
Madam?
Yes, sir.
Yeah. So can you tell me what is the intuitive fuzzy set? The definition of intuitive fuzzy set.
Sir, sorry? Intuitionistic fuzzy set?
Fuzzy set. What is the definition? Difference between
Intuitionistic
the general
fuzzy.
fuzzy set?
Yes, sir. Fuzzy set having membership value, but intuitionistic fuzzy set having membership and non-membership value. And then one more thing is hesitation value.
So how
that's
your problem is, why you apply your problem that the particular concept?
Because I gave the a complete value to the membership and non-membership value. Some of least facility means I gave the hesitation value. So that's why I have chosen this. Because in fuzzy set, give only one value, 0 or 1. In this case, 3 membership values are there. So that's why I have chosen the intuitionistic fuzzy set in this work.
Because there we have membership value and then non-membership value and then
hesitation.
In between there's hesitation values there.
Yes, sir. Yes.
So how?
Sorry, sir. I can't able to hear your voice.
Why you adopt particular problem? Because you are getting data, right? From the 3 villages.
Hello.
Sir, your voice is not audible, sir.
Am I audible now?
Yes, sir.
Hello? So
Yes,
why
sir.
you use particularly the particular concept on your problem?
Because I have collected this data from NSS team. So these are the primary data. So just I want to apply the intuitionistic fuzzy set in primary value and get the results. So compared to the original report, I have successfully completed my solution.
Okay. Because why I'm asking, because there is a particular condition is there where you apply your intuitionistic fuzzy sets.
Yes, sir. In picture fuzzy set also having one refusal membership value. So compared to picture fuzzy set, it's intuitionistic fuzzy set will give the better solution because the point accuracy level is too good in this set.
So
because already
okay.
I used this intuitionistic fuzzy in medical diagnosis problems. So applied to picture compared to picture fuzzy set, I felt it's far better, sir.
Because intuition fuzzy set is always for membership value or non-membership value as well as the hesitation. The hesitation is always there, whether we take it or not. Whenever that hesitation comes, we can use this idea.
Yes, sir, sure.
Okay.
Cosine similarities already exist, or the new concept which you are?
Yes, ma'am. Cosine similarity exists, but I applied the modified cosine similarity here.
So in what way it is different from?
This is my modified cosine similarity measures. I gave some changes in the formula and then analyzing factors.
What is cosine similarity measure? Whether you are shown here, how it is related? Cosine similarity and modified cosine similarity, how?
In one of the existing approach, cosine similarity measure applied in the fuzzy set only. So that's why I have chosen to apply to the cosine similarity in intuitionistic fuzzy set. That's why I gave some changes in the formula.
If you are in cosine similarity for your problem, how this will change in the modified cosine similarity? How these two are related? That's what I'm asking.
Because the WI is some main factors only I have chosen. So all 10 factors are there. Applied to the all 10 factors and especially to take 5 factors. So it will help to give more accuracy level.
Okay. Next person.
Next presenter,
Thank you.
Mr. Sudhir Kumar. Sudhir Kumar, sir, are you ready?
Yes, ma'am. Is it visible, ma'am?
Yes, sir. Yes, sir. Kindly open your PPT, sir.
Yes. Thank you, ma'am.
Yes, sir. You can continue, sir.
Yes, ma'am. Good morning. Good evening, everyone. The topic of my presentation is proposed technique to solve optimization problem using fuzzy and intuitionistic fuzzy sets. I am a PhD scholar. My name is Sudhir Kumar. Under the guidance of Dr. Anita Kumari, Department of Mathematics, Dr. Shyama Prasad Mukherjee University, Ranchi, Jharkhand, India. These are the outlines of the paper: abstract, introduction, related work, problem in existing approach, proposed methodology, result and discussion, conclusion and future work, and references. So this is abstract. Basically, in this paper, I develop a new algorithm to solve optimization problem, basically transportation and assignment problem, with the help of single algorithm. So transportations problem, and assignment problem. This is mathematical formulation and mathematical formulation of assignment problem. Related work in 1941 introduced a fundamental concept of crisp transportation problem. Later, Dangees GB in 1963 present a transportation algorithm for solving a transportation problem with equality constraint. Gupta and Arora in 18, and many other researchers have
Sudhir sir?
addressed. Yes, sir.
Sudhir sir, you can directly go to your problem, sir. You can
Yes,
directly go
yes,
to
sir.
your
Thank you, sir. Problems in existing approach. There is need to find a basic feasible solution. Some method available, like Modi methods or northwest corner methods, VM, Vowel approximation method, to find a basic feasible solution. Optimality test, computationally, it is not a simple. It take more time to solve a problem. Sometimes it gives feasible solution but not an optimal solution. Existing method is not helpful to solve a complex problem. So proposed methodologies basically develop proposed algorithm to determine optimal solution. Step one, there are three distinct optimization problem to be to consider. Crisp optimization problem, fuzzy optimization problem, and intrinsic fuzzy optimization problem. Basically, if problem is crisp optimization problem, it convert into crisp optimization problem converted into linear programming problem. How to convert it into linear programming problem? Suppose we have a 4x4 order, anyone, maybe transportation or assignment problem. Suppose 4x4 order transportation problem or crisp transportation problem, maybe balance or unbalanced. There are 16 element in this post matrix. So first of all, define linear programming problem in max z or min z according to problem. If problem is minimization, then take mean z, or problem is maximization, take max z. So how to convert? There are 16 element in this cost matrix. So assign 16 variable and multiply and add them. So define max z or min z, and subject to the constraints, adding each row. So first adding for first row and equal to the demand, and next row, and so on. Then for columns similar way. So if problem is 4x4 order, then
Sudhir sir.
Yes, sir.
Sudhir sir, whether you can you move your PPT because it is still in step one.
Yes.
You just tell your idea, sir, no problem. So here this algorithm is there. So you
Sir,
just tell
sir,
how your algorithm
algorithm,
is working.
sir,
You just tell how your algorithm is working.
Yes, sir. Yes, sir. Sir, if problem is there are basically three distinct type of problem. If problem is clear, then convert into linear programming problem, and linear programming problem solved by pulp library in Python.
Okay, you can
Problem.
move on. You can move on, sir. Move on. Okay, steps, no problem. You can move on. You have
Yes,
any
sir.
example? You have any example for this?
Sir, in the PPT note, so sir, but in paper there are 7 fully solved examples.
Okay, you can move. You move your presentation. So you have step 1, 2, 3. After that,
Sir, yes, sir. Next, result and discussion, sir. These are ranking method.
okay. But here you are telling you are right. See here you are give your algorithm only, right? You are telling you can, but the real thing will come to know only if we see the problem. Because in the algorithm you can write, but how you apply the algorithm in the real applications, right? So have you shown it in your paper? Can you tell
Yes,
one
sir.
simple example? Any example for this? Any real life example for this?
Sir,
Any real life example for your particular algorithm?
sir, consider in paper, sir.
No, no.
Real
So,
life
right, paper is
example.
there. So can you
Yes.
tell any one example? Any one example in your paper?
Sir,
Where we can apply this idea? Because you are telling you are proposed technique to solve optimization problems using fuzzy and intuition fuzzy sets, right? So
yes, sir.
can you tell any one problem where we can apply this?
Sir, like aggregate planning, scheduling, sir.
No, no. Scheduling, no.
Communication
Scheduling, there is
network.
no, no.
Yes.
Any simple problem, any simple example. So when is the same question I'm asking? When intuition fuzzy set comes into play?
Yes, sir.
Hello. When
Yes,
when
sir,
we are
voice.
going to use when you are going to use intuition fuzzy set?
Sir, it is better answer, sir. More
No, no, no.
accuracy, sir.
So see,
Yeah.
no, no. Because intuition fuzzy set comes into play whenever you have an hesitation in your membership value, right? That time only intuition fuzzy set comes into play, right? Suppose if you take a survey on election, then some people say I will vote for A, some people say vote for B, and some people on hesitation, right? Whether vote A or B, right? So in that type of problems only you can use the intuition fuzzy sets. There we have a membership value, non-membership value, as well as the exclusion value.
Yes.
Right? Okay, right? So whenever you try to do something new, right? You try to understand where it works and how it works. Right?
Yes, sir.
Okay. 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 Madam, come to you, madam. You want to ask?
No question. No question, you can leave. So, sir, you can leave.
Yes.
Next person,
Ma'am.
ma'am.
Thank you.
Next presenter, Miss S. Priyadarshini.
Yes, ma'am.
Priyadarshini, kindly share your PPT, ma'am.
Okay, ma'am. Ma'am, screen is visible. Ma'am.
Yes, you can move on.
No, ma'am.
Ma'am, screen is visible.
Screen is
Yes,
not
yes, ma'am.
visible,
It's
ma'am.
visible.
Go
It's
on,
visible.
go on.
Good evening to all. I'm Priyadarshini I'm pursuing MSc Biostatistics from SDNB Vaishnav College for Women. My topic is a statistical study on benefits and effective future of students learning through online education. Introduction. The objective of the study is to examine the benefits of online learning methods for college students through an online survey. A specially designed questionnaire was distributed among college students with approximately 450 participants from various colleges in Chennai. The survey consisted of 32 questions to assess the impact on student satisfactions and performance. Factor analysis and SEM analysis were used to analyze the proposed hypothesis. The SEM analysis has revealed that 4 independent factors significantly influenced the study. This study explores the benefits and future effectiveness of online classes based on students' learning experience, tutors' ability to foster a positive visions, and enhance students' learning experience significantly contributed to the received benefits of online education. The findings suggest that students' learning experience and their focus on time management play a key role in ensuring a successful future for students in online education. So these are my papers to review my study. Literature from the previous studies have been done on the study of online class satisfaction and performance of students. Methodology, factor and sum analysis are used for this study. There are 6 factors are classified. The first factor refers to benefits of online classes, and the second factor refers to managing classrooms to create a positive learning environment. The third factor refers to online classes is effective way for future learning studies. The fourth factor refers to learning experience in online mode. The fifth factor refers to managing time during online classes. The sixth factor refers to making online class interesting. So the diagrammatic representation of the model shows the relationship between independent and dependent variable. So the independent variables are students' time management, tutors' positivism, and students' learning experience, and tutors engaging students. The dependent variables are deemed benefits and effective futures. So these are the 6 factors. The factor one consists meeting interesting people, individuals' attentions, real world skills, offer flexibility, and the factor 2 consists global perspective, self motivations, virtual collaborations. Factor 3 consists build positive relationship, active engagement, encouraging collaboration. Factor 4 consists set goals of study, goals for studying, working on one thing, start working early. Factor 5 consists higher studies, well placed freelancer job. Factor 6 consists using different tools, trying flipped classroom method using AI. So result and discussions. So we conduct a sum analysis. So the fit indices. The fitness indices for structured model are shown when all variables are combined and all model fit values fall within a specified range. This indicates that the model has a high model fit. And the second table, parameter estimates the latter dependent construct outcome of online education and the latent independent construct features of online education. This table shows all the measurement indicators of the independent latent constructors are statistically significant. And the third one is standardized regression weights of structural education model of the nature of online education, benefits of online education, and effective futures. This table shows the BONC and MCPL and LEOM and MTON are significant, show significant values, and OEIFS and MONI LEOM are significant. So this table a positive influence of learning experience and benefits of online classes leads to 0.527 increases BONC. The statistical significance of the relationship, the critical ratio, indicates a highly significant relationship. Confirming the LEOM significantly predicts the BONC. Negative influence of effective futures of students. All 4 latent constructors negatively impact the effective future of students through online education. Significant predictors of effective future of students among the 4 constructs making online class interesting and learning experience in online mode are statistically significant in predicting the effective future of students through online education. Conclusion, the study examined various factors related to studies online class during the epidemic. This study explores the benefits and effectiveness of online learning, focusing on students' experience in an online environment, teachers' ability to make class engaging, the students' time management skills while learning online, and how teachers create a positive classroom atmosphere for learning. The students' emphasis on time management, teachers fostering a positive outlook, and students' overall learning experience all positively contribute to the perceived benefits of online education. This study highlights that students' learning experience or their focus on time management are essential for ensuring a successful future in online education. These are my references. Thank you.
Priyadashini, what's the conclusion finally you are giving? Online education is.
Ma'am, please repeat, ma'am.
What's the conclusion you are giving? Whether online education is good or
Ma'am, learning experience and time management are essential for ensuring the successful future in online education.
Hello?
okay, ma'am.
Ma'am, can you hear my voice?
Yes. Sir?
Johnson, sir.
Madam?
Sir, is there any question? Yes, sir. Yes, sir. Audible.
That's basically. No. So basically, let's see, since you are an MS student, right? So whatever work you have done is a good one, right? Because and you are also from biotechnology, right?
Please tell again. I can't hear you.
Are you from a biotechnology? You are MS student from biotechnology.
Yes, sir.
You are MS student from biotechnology, right? Hello?
Yes, sir. Yes, sir.
You are MS student from biotechnology, right?
Yes, sir.
Okay, right. So whatever work you have done, it's nice, right? But in future, you can go the same thing for in research purpose, right?
Okay.
At MS level, it's good. The work you have done is good, right? But in future, you go for PhD and research work, that you can still move on, right? At this level, it's whatever work you have done is good. Madam,
Sorry, sir. I can't hear your voice.
Madam,
Sir, as a MS, you are good. So continue your thing and do your research. Continue your research, he says.
Okay, thank you.
All the best. Good night.
Thank you, sir. Thank you, ma'am.
Next presenter, Yuvarani ma'am. Yuvarani ma'am, are you ready?
Yes, ma'am. I'm ready.
Kindly share your PPT, ma'am.
Yes, ma'am. Ma'am, is my screen is visible? Is my PPT is visible? Ma'am?
No, ma'am. No. You are audible but not visible, ma'am. Share your screen. Yeah, now it starts.
Is it visible now, ma'am?
Yes.
Yes, ma'am.
Okay. So good evening to one and all present here. I am C. Yuvarani, working as assistant professor in the Department of Mathematics from DRBCC in the college. And today my presentation is on... Sir? Sir, your voice is breaking, sir. Sir?
You just turn your mobile. She is at as a full screen and then present it. Turn your mobile now. You are having a mobile now, so
Yes, sir. Is it okay now, ma'am?
yeah, now it's okay.
Okay. So today my presentation is on graph theory based encryption using vertex odd mean labeling and topological indices. So this is the outline of the presentation. So as in day-to-day life, cryptography ensures the security of data. So graph theory is widely applied in cryptography. So by using various techniques of graph theory, we can mask the data And already we have some existing methods for encrypting and decrypting, but in this work we proposed a vertex odd mean labeling method together with the topological indices. So this method combines vertex odd mean labeling together with topological indices, and the general graph is also used, and its complement is also used for the process of encryption. And together with that, concurrence equations also applied for encoding and decoding messages. So this is the general graph where the vertices are given to be a odd number, where the vertices are labeled to be a odd number, and the edges are labeled with a even number, which is the average of the corresponding vertices. And here the congruence equation which we are going to apply is given here, that is C concurrence to AS plus K mod 43. So, and the topological index which we introduced in this paper is Vienna index, which is defined to be the shortest path length between all the vertex pair. So the topological index, since it quantifies the graph structure, so it will be helpful in the process of encryption and decryption. So this is the encryption algorithm we proposed here. So for each and every character, we have assigned a ordinal number. So here we have used 42 characters. So it is assigned from 0 to 42 ordinal numbers. So with the help of that above table, we can easily convert each and every character into an ordinal number. And from the ordinal number, with the ordinal number, we can generate a general graph. We can derive the general graph whose vertex, whose edges have that ordinal number. And for that derived general graph, index using this formula. And after finding the Vienna index by using this affine Sapphire, that is the concurrence equation, C concurrent to AS plus K mod 43, we can again encrypt the numbers, where A is the Vienna index of the derived graph, and S is the sequence, ordinal sequence, which we got by using the first table, and K is the number of edges in the derived graph, and 43 we have taken mod 43 since we have used 42 characters. So we have taken mod 43 here. So with the help of this step 4, we can obtain a sequence of encrypted numbers. And again, the encrypted numbers are converted into letters by using the same table. And then we will arrive at an encrypted message. So the receiver will be receiving the encrypted message together with the complement of the derived graph. So after the receiver received the graph and the complement graph and the encrypted message, he is to decode it with the help of the following procedure. So to decode the encrypted message, first it will be converted into ordinal number with the help of the first table, and then again it will be solved by using this concurrence equation, and where the Vienna index A and the number of edges can be found by using the complement of the graph. And then after finding the values for S for each and every value of C, for each and every value of C, you can decode the value of S. So you'll get the a sequence of decrypted numbers, which is denoted by S. So S is the sequence of decrypted numbers, and for each and every decrypted number, we can find out the original character, which gives original message. So to ensure this algorithm, we have used an example here. So to encrypt the message graph, so we have taken the first table, and with the help of the table, each and every character has been assigned a number. So from that, by using the general graph, we have derived a graph which has this ordinal numbers as their edge values. So which is given in the left side of the presentation. So this is the graph which is derived from the general graph, and it is extracted from the general graph whose edge numbers are nothing but the ordinal numbers for the message. And we have taken the complement of the above graph to make the process more to make the complement of the That is to make the process more complicated. We have introduced the complement of the graph here. So for the extracted graph, we have taken the complement here to include to make the complexity. Make more complexity, we have taken the complement, and we have found the Vienna index for the graph. And by using that, we can find out for each and every ordinal number, we can find out the encrypted number using this concurrence relation, C concurrent to 21S plus 5 mod 43. So S is nothing but the ordinal numbers corresponding to the letters G, R, A, P, H, that is 6, 17, 0, 15, 7. This is the sequence S. And for each and every sequence, for every member of the sequence S, we will get a member for C, value for C. And again, it forms an encrypted sequence for which is given here, which is 2, 18, 5, 19, and 23, which is the encrypted sequence, and it is denoted by C. And again, the encrypted sequence will be converted into a encrypted message, and this encrypted message will be sent to the receiver together with the complement of the extracted graph, and it will be decrypted by using the procedure which we seen already. So the encrypted message will again converted into a ordinal number, and then each ordinal number will be again solved by using a concurrence relation, and we will get a sequence S here again. From that sequence, again it will be converted into a original message. So this is the method we have introduced here. This is the algorithm we have introduced here. So our algorithm is novel method because for encrypting and decrypting the messages, we have used the topological index together with the vertex odd-min labeling network, as well as we introduce the graph complement. So this ensures the security of the data, since the procedure, encryption and decryption procedure is more complex by introducing the complement technique. So this is what the method we have proposed in this paper. Thank you, sir. These are the references.
This presentation. Why don't you go to the graph you are showing graph word you are showing and giving the graph with the edge labeling, right? Go to
Yes,
that
ma'am. This one, ma'am?
No, example.
In example, okay, ma'am. This one.
This one, yeah. Why don't you explain this? Edge labeling is 617 something. How you are drawing this graph?
Yes, ma'am. We are extracting this graph from the original general graph, ma'am. So we are extracting that from here, ma'am, from this graph. So from here, actually, this is designed how the vertex are labeled with odd numbers, where the edges will be labeled with the even number, which is nothing but the average of the corresponding vertices. So for the given message, we have some sequence of numbers, ordinal numbers. So that ordinal number, it will be in the edges which has those ordinal numbers will be extracted from this graph, ma'am.
Okay, this is a general graph. In this, you are taking all those things, right?
Yes,
okay.
ma'am. Yes, ma'am.
Whether you
Ma'am?
you did any program?
No,
Whether you
ma'am.
did
No, ma'am. That is our next step. That is with we are trying to develop a Python program for this algorithm, ma'am. We are working on that, ma'am.
Okay, fine.
Thank you, ma'am.
Okay, madam. Okay, good. Good.
Thank you, sir. Thank you.
Thank you so much, sir, and thank you so much, ma'am.
Thank you,
madam.
ma'am.
இதுல எல்லாமே தாங்க ஒருத்தர் வந்து இல்லையா மேடம்? இந்த ஒருத்தர் நடுவுல சஹீரா பண்ணுவா மேடம்?
Lakshmi not Lakshmi and Tagira Banu. Lakshmi and Tagira Banu not present.
Okay, Matalam. Okay. Thanks.
Now it's time
thank you,
to. Now it's time. Thanks. I could like to give my sincere thanks to chairpersons, Dr. T. Johnson, sir, Professor and Head of the Department of Mathematics, Dr. MGR Education and Research Institute, Chennai, and Dr. A. Tamil Selvi ma'am, Assistant Professor, Ramanujan Institute for Advanced Study in Mathematics, University of Madras, Chennai, to grace this section. Thank you, sir, and thank you, ma'am. Now, I would like to extend our sincere thanks to our managing directors and trustees of Sri Krishnaswamy College for Women. I would like to extend our special thanks to Dr. R. Anita Rajendran ma'am, Principal, Sri Krishnaswamy College for Women, for her support. My sincere thanks to Dr. R. Esther Felicia ma'am, Head of the Department of Mathematics, for her guidance. Now I extend our sincere thanks to all the participants from various colleges for making this section a resounding success. Once again, I thank you all for your presence. Thank you, sir. Thank you, ma'am.
Thank you, ma'am. Shall we leave?
Yes, sir. Yes, ma'am.
Okay, thanks a lot. Thanks.